Hello. Welcome to HashiTalks Africa. Um, my name is Wale Sorry, I can hear myself. Just bear with me real quick. Is this sorted? Okay, awesome. Right. Yeah. Welcome to HashiTalks Africa. My name is Wale Salami. I'll be your MC for today. Later on, you'll be joined by my co-host Patrick. So before we start, let's talk about some house rules. So if you have any questions or comments, we'd love to hear from you, see you interact with us in the chat. As you do, please keep in mind our code of conduct in this virtual workspace, in this virtual space, I mean. So in general, be welcoming, be inclusive, friendly, and patient, and also be considerate, be respectful, and be professional. And also, you can review the code of conduct at hashicorp.com/community dash guidelines. So, with that, let's get started. Our first speaker for today is called. His name is Eric, and he is going to be talking to us about securing cloud workloads with HashiCorp Vault, a practical guide for African enterprises.
Okay. Please, can you hear me? Hope everyone
Yes,
can
we
hear
can hear
me.
you. We can hear you, Eric.
Okay, great. It's a pleasure to be here. So my name is Eric Nyeze. I'm a cloud and DevOps engineer with over 5 years of experience. And so I work with SolarBase Technologies Institute as a cloud and DevOps engineer. And I'm also the HashiCorp user group co-organizer for Accra, Ghana. And so during this session, um, we're going to be looking at how African enterprises can secure their workloads, with HashiCorp Vault, right? And this is going to be a very practical guide. It's not only going to be a talking session. And so let's look at what's at stake, right? So why all this? Why are we talking about HashiCorp Vault today, and why does it matter so much? You know, growing back and also maybe in some remote villages, I'm not want to say in Africa, but in some remote villages, you will notice that people still have to dig holes to get water to drink. People have to drink water from flowing streams in open spaces. And so when they do this, they are more prone to diseases and ingesting bacteria and all sort of, unhealthy lifestyles, right? And so as humans, we keep on evolving. We keep on evolving. And when you come to the cities, you see that people want to drink water from water sachets, right? Because they believe that water in the open is not safe. Water in the open is not safe since it's prone to germs and all of that. So they want to drink water from a sachet, right? So they can easily hold it, grab it, and then drink it and they dump the sachet somewhere. And so there is also another group of people who want to drink water from the plastic bottles, right? Because they believe that with the plastic bottle, it's more trustworthy, right? And also you can carry it anywhere along. You can drink it tomorrow, keep it, and then continue drinking. You can drink it today and then continue drinking tomorrow, right? And then there's another group of people who say, if I'm drinking from the plastic bottle, it's not safe for me. Someone might come and then maybe they inject maybe some poison or maybe something to maybe affect my health, maybe through a needle because it's plastic. They want to drink from a glass bottle, right? Because of that, you are more assured of your health. And so that is how we've evolved as human beings in terms of making sure we want to live healthy, in terms of making sure we want to live, lives that are free of germs and all of that, securing our lives, basically, right? And so this cuts across not just with human beings, but also with technology. And that is why today we see that a lot of African enterprises, a lot of African companies, organizations are now adopting cloud technology, right? And we realize that cloud technology is fast growing. And according to McKinsey, this was last year, they realized that 45% of workloads in most of African companies are in public cloud. And this is so interesting, right? And above that, there are more companies that want to move to the cloud. And this is 61% of companies that want to move all their operations to the cloud within the next 2 years, right? This was last year. So maybe let's say next year, 2026, right? They should be moving their workload to the cloud. And so with this mass adoption of cloud technology, there are two things in play here, right? The increase in that momentum, that increase in adoption of cloud technology, and then secondly, the increase in cyber attacks, right? As more companies are moving to the cloud within the African ecosystem. And so we have the bad guys too, right? Talk about cyber criminals who would also want to move to the cloud, to hijack systems, infrastructure, applications, and all of that. So this is posing a high security risk. This poses a high security risk for companies in Africa, right? You might get up tomorrow and you hear that maybe one of those fintechs in Nigeria, right? Since Nigeria has become, a fast-growing environment for fintechs, you might hear that maybe one of the API keys, is leaked because it's hard-coded, right? Because it's hard-coded, maybe it's leaked. What happens? Your funds, your money, everything is gone, right? Or maybe, let's say in Accra and Ghana, where I am, there could be a reputable healthcare facility organization, and you hear that the patient's database, is leaked because maybe they're one of the administrators or maybe one of the healthcare facility, workers, they mishandled the credentials for the database, right? So this is going to pose a lot of security risk for companies in Africa as they are, migrating to the cloud. And so as a solution, this is why we are introducing HashiCorp Vault as a solution for enterprises in Africa, right? And so what is HashiCorp Vault? HashiCorp Vault is simply, a tool provided by HashiCorp that helps companies to centrally manage their secrets, right? They can centralize the management of their secrets, as simple as that. And so it also goes beyond just that. It goes beyond providing encryption as a service, right? So you can encrypt your data to make sure that data moving from one user or maybe from one of your colleagues is encrypted. You don't just want to get your data moving through the pipeline as plain text, right? You want to make it in ciphertext. And also, as companies are becoming more dynamic, right? Because in a company or in a setup, you could have different teams, different environments. Maybe the dev, the test, the prod and all of that, right? You have developers that are creating new features, updating, and all of that. We see that environments are changing. They are so dynamic. And so the best solution for a company to manage their secrets or to be able to handle that kind of a dynamic environment is HashiCorp Vault, right? And so in this diagram here, on this image here, we see Vault API here as, the manager. Let's consider ourselves, we are in a bank, right? And then as a bank manager, one of your subordinate comes to you and they want to access, let's say, the server, for example, if that's possible, right? And you don't just want to give them open access to the server. You want to give them keys. So you as a bank manager, considering here you are the Vault API now, what is going to happen is that the Vault API is going to create the secret, right? And then give it to that subordinate and say, hey, you, John, take this secret for you to go and access the server, right? You do this from this central point where we have, let me just bring on my pointer. So this is you here as the bank manager, right? So you create the secrets and then you give it to your subordinate, right? And that is not all. You might want to share data with your team or with your colleagues, right? Again, Vault API is able to do that. you kind of encrypt the data, right, before putting it into a pipeline, so that if by mistake the data gets leaked across the pipeline or within the pipeline, the person who is having access to it won't be able to understand it because the data is just scrambled, right? The data is scrambled and they won't be able to understand it. So until it reaches the destination and the user has access to it, he decrypts it. So then you see that Vault is a secured tool for you to use when you want to encrypt your data. And above all, you see that Vault also helps you to integrate other cloud platforms, right? Like AWS, Azure, GCP, and so on. So it provides like a secondary layer of security for your cloud environment, right? So that is basically what Vault is all about. And so we look at the features of Vault, right? The first feature is that it provides a centralized secrets management platform. You don't want to have different platforms for you to manage your secrets for your users and for your resources, right? It also provides you with dynamic secrets. Dynamic secret here means that provided an auditor comes in your environment, right? You don't want to give them permanent access, let's say, to the database, or maybe for the environment where they want to do their auditing, right? You can just create a short-lived, database credential, and you give it to that auditor. And within the time that you've, stipulated, let's say 2 minutes or 5 minutes, they can have access to the database. And after that, his credentials and him as a user, all of that is going to be revoked. And this is done automatically. You don't have to do anything. You don't have to hard code the credentials or the secrets, right? So Vault also provides encryption as a service. Like I talked again earlier, you can encrypt your data in transit and at rest, for your users, right? You want to make sure that if someone has access to your data, they can be able to view it. They can't, delete it or do whatever with it. They can have it, but it's encrypted. They can't do anything, right? So the fourth feature of Vault is that it provides audit logging and access policies. So when you're working with Vault or when you've installed Vault within your system, right, it takes logs. And so tomorrow, if an auditor comes, to check and see, make sure that you are implementing, let's say, best security features or best security practices within your environment, right? Vault is just going to provide them with that data without you having to do a lot of work. It's going to make your work easy, and you can create policies, right? For your team. And above all, the good thing too with Vault is that it works across both cloud environment, hybrid, and on-prem environments. That is a good thing, right? Whichever environment that you're operating from, right? And so for the sake of this session, our focus is going to be on how you can leverage Vault within the cloud environment, right? So that's how our session is going to be. So we're going to have a quick live demo to see how practically you can implement or take use of Vault within your environment. And so what we're going to do during this session is that we're going to test Vault and see how you can access the database, right? It's going to create short-lived credentials for us to access the PostgreSQL. So the first thing is to make sure that Vault issues the dynamic database credentials. That's the first thing. And then we're going to generate a short-lived user, right, via Vault. Let's say consider that the user is, let's say, an auditor who has come in, right? Or maybe a DevOps engineer who has come maybe to resolve an issue. And then thirdly, we are going to connect, to the PostgreSQL, right, with the credentials. We are going to connect to the database with those credentials. And fourthly, we are going to observe a time to leave, right? Like I said, we're going to set a time. It could be 1 minute, 2 minutes. I will say, hey, after this time period, you're going to be revoked. The user is going to be revoked with his credentials, and they won't be able to have access to the environment again, right? And so that takes us to the fifth point where we are going to revoke the user's access and then test again and see, after revoking, are we going to be able to access the database with the same credentials and with the same user, right? And so at the end, we're going to see that nothing is going to be hard-coded, right? Vault is going to take care of the credentials for the database, and everything at the end of the day is going to be auditable, right? So that is how briefly and shortly our practical session is going to be. So just give me a second. Let me switch to my environment where I'm going to do the demo. Let me stop sharing, and then I bring up my other environment. Okay, please, can you see my Git bash? Can you see my environment where I'm going to do the environment where I'm going to do the demo? Just confirm. Let me know. Oh, you can see it. Just a second. I thought I'm sharing this. Let me stop sharing again. And then I share. Oh, okay. All right. Just my face. Right. Let me bring up my Git bash. Okay, please, can you see now? Just confirm.
We can see it.
Okay, thanks for the confirmation. Thanks. Guys, so yes, so we're going to practically do this, right? This is going to be very practical. So what we're going to do is that first, we would need to, just a second, just hold on. So during this demo session, right, we will need our Docker desktop. That's the first thing that we need. We need our Docker desktop, and then secondly, we will need the Vault CLI, right? We are going to run our Vault commands and all of that. So these are the basic requirements that we need for this demo session, right? So I already did that from my end. I'm just going to go straight away with the next step where I'm going to create, I'm just going to call it the demo files, right? For this practical session, so that you see how you can create your folders and your files where you're going to run your commands and all of that. So I'm going to create the demo files, right? And I'm going to create first the directory, let's say project directory for this our session. So I'm going to call it the Vault demo, right? So I'm just going to create it right away. I'm going to create it right away. And then I get into it, I cd into it, right? So when I get into this directory, right, I want to create a Docker Compose file, right? And this Docker Compose file, we're going to call it demo compose.yaml, right? Let's call it Docker Compose, demo compose.yaml. I'm just going to copy everything and paste for the sake of time so that we save time. So this command, oh, sorry, I forgot the nano. We're going to link to nano into it. Okay, so let's create a file. I'm going to paste the entire file here so that we all see. So what this file does is that the basic thing that it's going to do, right, is going to create a container, right, and then install Vault. This version, this particular version, is going to create a container, and then it's going to create also the port for Vault, which is 8200, and then it's going to also create the environment, which is going to be, we're going to use the root ID, right? And then the second thing it's going to do is that it's going to install the PostgreSQL, which is version 14, right? And then create the user, and then it's going to create a password, and then the name of the database, and then the ports for PostgreSQL, which is 5432, right? So basically, that's what this this file is going to do, right? Let me just come out of it. And then the next thing that we are going to do is that we are going to start the container, right? Like we saw, we just created a container. We are going to start that container. We run this command. I have the commands here. At the end of the session, I'm going to share the runbook for anyone who wants to practice this, right? So we're going to run the container in detached mode. Okay, that's the container being created. We're starting it. Okay. And so we started the container. Now let's verify, right? Let's verify that the container is running. Let's verify the container is running. Okay, perfect. We see everything is there, right? The Vault demo, PostgreSQL, the ports and everything. So it's running, right? And then the next thing we're going to do is that we need to connect this Vault CLI that we installed, to the Vault server, right? We need to do that connection so that they can communicate, without which we cannot be able to do anything, right? So these commands I'm going to run here, they are going to do all of that. Okay, that connection has been, established. Now let's verify. Let's verify to make sure that the connection has been established. I'm just going to run Vault status. Perfect. So the connection has been established, right? So what we see from here is that the key thing to note here is this sealed key here, right? So this sealed key here tells us that the value is false. That's telling us that we've unlocked, we've unlocked the Vault server, right? It's no more like it's no more blocked. So we've unlocked it so that we can be able to proceed with our session, right? And also another key thing to note here is how can I call it? Anyway, that's not so much important, right? Let's just proceed. Now, the next thing that we're going to do is to enable the database secret engine, right? The database secret engine. And so we just run this command to enable that. Perfect, success. So it's telling us that enable database secret engine at database, right? So that has been done. Now let's verify that it's enabled. We just run our Vault secrets list to check. Perfect. This is enabled. We can all see everything here, right? Now, we will need to connect the Vault to the PostgreSQL, right? We need to establish that connection. We already established the connection between the Vault CLI and the server. Now, it's important for us to connect Vault to the PostgreSQL, right, to the database. So all of these commands that I'm going to run here, they're going to do all of that, right? For the sake of time, I will have explained what each and every command here is going to do. But in the runbook, you're going to get everything detailed, right? So that has been done. Success. Data is written to a database config my database, my DB, right? That is being done. Now, we will need to create a role, right? We'll need to create a role. Let's say it's an auditor that's coming into our environment, right? We're creating the role for that editor who has come in. And he's going to be there just for 2 minutes, right? He's going to be in our environment to do the auditing just for 2 minutes. After that time, he's going to be revoked. The credentials and him as a user, everything is going to be revoked. So these commands here, they are going to do all of that, right? It's going to create a rule with a 2-minute expiry, right? So everything here is going to be done. Perfect. So that has been done. Data returned to database with the rules, my rule, right? Now, the next thing is we will need now to generate the credentials, right? This is where the beauty of Vault also comes in. It's going to generate the credentials for us. We will not need to hard code anything. We will not need to hard code anything, right? So let's first of all set up the data first. We need to first of all set up the data through these commands. We see this is the data. It has someone's email. We're calling him or her Alice, right? That's the name. So that's the data that we've set up first. And then secondly, we are going to generate the temporary credentials for this user, right? We are going to generate temporary credentials. And the role that we're giving him or the permissions we are going to give him is only going to be read-only access, right? They can't delete, they can't create. It's only to read for 2 minutes. For 2 minutes. So this command is going to do all of that. Perfect. So we've seen the password already created. This has been generated by Vault. This is the password. And also this is, we are saying here true, the list is renewable if you want to, but we don't want to, right? And the list duration is 2 minutes. And the password, this is the password Vault has generated. And then this is the username it has also generated, right? And then now let's test these credentials we created, right? Let's test to see if it's going to work. So this command here, we're going to run it. But before running it, we'll need to replace the we need to paste the vault username here, right? So let's delete this. We're going to use the username that vault has given us, right? This is the username. We're going to paste it here. So we run it. And so it's asking for the password, right? So this is a part, provided you are the auditor, this is what you're going to get, right? This is the password that Vault has generated, and you're going to use, to access the database. So just get this password here. Okay, so I've pasted the password, right? And so it has taken me to a database, right? It has taken me to a database. Now we will need to then say, get into the database and do the read access rule, right? Let's get into it now and do that. To read the database, see the content of it, right? With this command, it's going to take us there. A second. Do this. A second. Okay, so this is the content of the database that we, as as auditors or whoever we are, we have access to, right? We see the ID of the user, which is 1. We see the name, and then we see the email, right? So this is how we're accessing the database. Now let's just quit, right? Let's quit out of this environment. And then say, we give ourselves 2 minutes, right? To access this database, right? Let's just wait for 2 minutes to expire. But one thing you will notice that I decided to break these into step by step. I will have run just 3 commands, right? I will have run maybe just 3 commands and all of this will be done. But again, we will not understand the concept behind what I'm doing. So for the sake of our understanding, I decided to break the step by step so that we understand what the commands are doing, right? And how it's going to help us achieve our goal in this session. So for those who are having questions, you can just drop them in the YouTube channel or in the chat. After the session, I can get back and then I respond to that, right? So like I said again, also, after the session, I'm going to make the runbook available. I'm going to make it available so that you can practice, see how you can implement Vault within your environment, see how you can ensure encryption, create secrets, make sure that your environment is auditable, right? Yeah, so let's just hold on for, I think a minute is over. And then after that, we're going to test our secrets, our credentials to see whether we can be able to access the database again after the time to leave, which was set to be 2 minutes, right? So you're going to have it at, from my time here, is going to be at 18 minutes past the hour. So just wait for a minute, and then we can test the short-lived credentials. Right, you can test it. So we're just going to run this command. Let me just put the command here, the command we're going to run. The command we're going to run is going to do all of that for us to test and see that, hey, our time is expired, right? So I think 2 minutes should be over now. Let me just run it. 2 minutes should be over now. So this is the command here, right? This command again is just has our user, right? It has our user and it's telling us where we are going into the PostSQL database, the PostgreSQL database. So let's run it to see. Of course, it's going to ask for the password, but are we going to be permitted, right? Are we going to permit it? Let's get the password from here. Are we going to permit it? No. Right? We see that the time has elapsed. We were only given 2 minutes to access the database. And it's not only accessing, but read-only access. We can't edit, we can't delete, right? So we realize that Vault is able to create you short-lived credentials, right? Which you can, use in your environment to give it to maybe auditors or to people who are just coming for temporary, accessing your environment temporarily, right? So basically, that is what Vault is able to do, right? So that is just for us to see that with Vault, you can create short-lived credentials, right? You can create short-lived credentials. So I'm going to run this command to just clear everything in my environment. So everything in my environment is being removed, being deleted, right? Yes. So just to wrap up, let me get back to my screen. Let me get back to my screen where I'm supposed to wrap up. Just a second. Get back to my screen. Okay. So this is what we've been able to achieve, right? In all of this, what lessons have we gathered? We've seen that if you want to start with Vault, right? Always start small. If you haven't used Vault within your environment before, start small, right? Within the dev environment for experimentation. And then you can later move to production, right? With TLS and then on seals keys. And furthermore, you can integrate it within your CI/CD pipeline, right? You can integrate Vault within your CI/CD pipeline and then use policies and tokens for least privileges. Don't overgive permissions and don't undergive permissions, right? And above all, the good thing is that you can combine Vault with Cloud IAM, right? To ensure that you have security in layers, right? I always say that security in the cloud is in layers. It's not only about a particular firewall, right? You need to bring up layers that can protect your environment, right? And so, what is the call for action for us here, right? Unmanaged secrets are very risky. The key takeaways: unmanaged secrets are very risky. Be able to manage your secret is very risky, right? It's going to lead to breaches, and you're going to lose trust for your company, and you're going to go out of business, right? And also, Vault comes as a solution to enable you create a secure, dynamic, auditable secret for your environment, right? And so, what will be the next step for you? Go ahead and try, Vault today through this link, developer.hashicorp.com, HashiCorp Vault. So I want to thank you all for listening. My name again is Eric Nyeze. I'm a cloud and DevOps engineer with over 5 years experience. And if you want to connect with me, just scan the QR code. Let's connect on LinkedIn. Thank you for listening.
Thanks, Eric. That was really useful to know, especially the short-lived credential part where when an employee, for example, leaves a company, it means I don't have to worry about them still carrying on with my credentials, as in with my system credentials. So that's really good. But before we talk about the next speaker, we have my co-host with me now, Patrick.
Hi, Wale. Hi, everybody. How is everybody doing? I hope that you're having a fun time in this HashiTalks today. And I've just joined in when Eric was doing that awesome presentation. The presentation was really, really good. But about me, maybe before I go further, my name is Patrick Odhiambo. I'm a HashiCorp ambassador. I'm from Kenya, East Africa, and really, really happy to be serving as an ambassador for my first time this year. And HashiCorp has been doing great things, and I believe the many communities that are working around just to make sure that this good news about the good products that HashiCorp is doing is launching and bringing to the market is out there. So again, back to our speaker today. He has actually touched a very important point about security, securing our credentials, and since he has been our first, it already shows us how far we are going in our talks today and the awesome learning opportunities that you are going to get. So, Wale, who are we bringing next?
All right, thanks. The next person, sorry, we have two speakers actually next. So we
Uh-huh.
have Abdul Rasak and Ajose.
Mhm.
They're going to be talking to us about building highly available vault on a budget, i.e. Raft
Mhm.
plus MinIO for resilience. Oh, that sounds interesting. All right,
Very.
let's start.
Am I audible?
Yes, you are.
Yes, you are.
Okay, great. Thank you very much. Yeah, my name is Abdulrazak Salaudin. That's a very long name, but I would tell people to just call me Abdul for short. I mean, you can save time and data with that. I am a site reliability engineer at Deimos, and I'm not here alone. Of course, I have alongside me. So with me, I have Anu Olapa. Anu,
Yeah,
are you
good
there?
day, everyone. Thank you so much, Abdulrazak. Like you just said, I'm just say Hanulu Akpo, and I'm a DevOps engineer with Intrazact. It's such a pleasure to be here today at HashiCorp Africa. Thank you once again for joining us. So, yeah, have been working in the financial space for quite some time, and one thing has always been crystal clear, right? Secret management is non-negotiable, and I know that's true for many of us across other industry. But here's the catch, right? When most teams think about setting up a secret management platform, what comes to mind really is, oh, we have to implement strong encryption, we have to implement access control, and many others. But how often do we think about the high availability side of things? How often do we think about the resiliency of this platform we are setting up? That is disaster recovery, right? So, in a situation where your platform, that's your secret management platform, goes down and your application starts failing due to inability to fetch secrets, you have people running helter skelter to fix this issue, right? What plans do we really have in place to address such situation? So, and I believe this is a major concern for many of us on this call. So, I mean, what we've set up to actually secure our systems has now suddenly become a single point of failure. And this is something we all don't want for ourselves. So that's why today we'll be talking about making Vault work for you. So let's dive into the topic, building a highly available Vault on a budget using Raft for clustering and MinIO for disaster recovery. And at the end of the day, we are not just here to talk. The goal at the end of the day is to ensure that your secrets are not only secured, but always available when you need them. So now going into our setup, we've set up a 3-node vault cluster. As you can see on the screen, we have one master and 2 followers nodes. So another thing is we've set up a self-signed TLS certificate that's for secure communication within our cluster. And then we're also going with MinIO as our backup storage target. So like I said earlier, the goal is to achieve resilience in our various platforms on a budget. So yeah, talking about MinIO for resilience, and there are several reasons why we decided to go with this tool. First of all, MinIO is open source. It's readily available for every one of us. You don't have to go extra mile trying to use this tool. And it's also S3 compatible. It can run anywhere. You can deploy it as a container. You can deploy it on your bare metal VMs, anywhere. It's easily and readily available for you to use. And it's also very much perfect for storing Raft snapshots securely, and it also reduce your recovery time in case your cluster fails, the whole high availability talk. And then for our snapshot strategy, we are going with Raft's built-in snapshot feature. And so the whole idea is for it to capture our cluster states periodically, and then this snapshot will be pushed to MinIO for durability. So at the end of the picture is, okay, let's say your vault goes down, your cluster goes down, you can easily set up a new cluster, and then you restore your snapshot from MinIO, and voila, your services are up and running without any data loss. So yeah, for our high availability option, we are going with Raft, like I mentioned earlier. So why did we choose Raft? It's very easy to configure. It's built directly into Vault, so you don't have to do any complicated setup for it. It's also on-prem self-managed. You can just set it up on your on-prem infrastructure. You manage it yourself. No extra management. You don't have to pay for licensing and all of that. So yeah, it's open source, like I mentioned, native costing, and it's cost efficient. You don't have to pay for enterprise licensing. So yeah, there are also other options that we could have gone for. That's console, etcd, DynamoDB. But I mean, at the end of the day, what we are trying to achieve here is high availability on the budget. So that's why we are going with Raft. Yeah, thank you, Razak. Yeah, so now we'll be diving into what is Raft. I mean, I've mentioned Raft, Mina, and all of that. So let's deep dive into this particular topic. What is Raft? Abdulrazak, over to you. Thank you.
All right, thank you very much, Arno, for that. So, what is Raft basically? Raft is a built-in consensus protocol. It's not native to Vault only. We have other technologies that uses Raft for leader election. Things like Kafka and the rest of them. So it's not native to Vault only, but this is built into Vault technology. And what does consensus mean basically? It's just involving multiple people to agree on the same value. So if you have multiple people agree on the same value, that is basically what consensus is. And you can see from the architecture in the picture here, you have like 3 nodes, and then you have Raft integrated, and they communicate with one another to just agree on the same value. And I'm just going to take you to this page, which actually gives us a very good demonstration of how Raft works. You can see this is a 5-node cluster for Raft, and periodically they communicate. So an election is going to take place shortly. That's an election taking place. And you can see they all agree on selecting S1 as the leader, right? And periodically S1 keeps sending out nudges to all the remaining nodes in the cluster to say, I'm still alive and I still remain the leader, until S1 goes down. An election will have to take place. So let me simulate S1 going down by stopping S1. You can see the nudge is not going out anymore. And the other nodes are basically waiting for it until they time out, and they will have to carry out another election since they are still the majority, right? And you can see the election is taking place right now, and eventually they are going to select a leader. So let's wait for it. Okay, there you go. Now S4 is the new leader. So, it continues, and S4 keeps on sending nudges to all the other nodes, and even the one that goes down, just in case it comes back up, So the next thing I'm going to do is just take down the S4 node, which is the new master node, and we expect another election to take place. So I'm just going to speed this up a little bit so it's a bit faster. Okay, great. So they are still the majority. I mean, 3 is still greater than 2. So of course, election will take place, and you can see S5 is the new leader. And if I take down one more node, the S3, which is the new master node, the quorum will be broken because 2 is less than 3. So you need majority before you can carry out election. So if I do that, you can see the remaining 2 nodes will time out, and no election will take place. No new leader will be selected, right? But this just helps us achieve the whole clustering consensus, ensuring that at every point in time, you have the same data across all the other nodes. And this will keep going forever, and no new leader will be selected until I bring up any other node. So I can just bring up, oops. Okay, I think I just messed this up. All right, I'm just going to quickly stop the nodes. Okay, let's wait for the leader to be selected again. Okay, S5. So initially I stopped the S5, no leader was selected. Exactly, so if I bring up one more node, now the quorum will be formed again. You can see S4 becomes the new leader. And I can do that basically for the rest, bring them back up, and the cluster, the consensus will come back up. And we have our 5-node cluster communicating. So going back to our slide, so why did we even actually use Raft? Because we're trying to do simple. Most of the time, simple things solve the most complex problems, right? So no external dependency. Everything we're doing, except for the resiliency part, which is handled by MiniIO, by the way, is internal to Vault. And right off from Vault 1.4, HashiCorp advised that Vault is actually ready for production. It's production ready, meaning you can use the Raft protocol in your production environment. So when we're trying to set all of this up, we're talking security. So we need to make sure that every layer of our setup is secure. So the first thing we did was to create a certificate authority, and a private key was created. And after that, a certificate was created from our private key. And the next step was to create a key for each of our Vault nodes. And we created a CSR as well, which is otherwise called a certificate signing request, which is later going to be signed by the CA that we created initially. So after the CA signs the CSR, it creates a TLS certificate that we can use to achieve encryption in transit when you're communicating either from outside of the cluster or the nodes are communicating with one another within the cluster. And the next thing is the Vault configuration, which is where you actually state clearly that you want to use Raft. And as you can see what we have on the screen from line 1 is just showing that UI is enabled, just meaning that you can communicate with Vault via the UI. And 4 to 6, stating clearly that you're using Raft. And you have 8 to 29 that is actually, this will be configured on all of the Vault instances. And this is just telling one Vault node the configuration of the other Vault node so that they can easily communicate with one another, the IP address and also the names to be able to send nudges to all the Vault nodes when election is taking place. And you have 31 to 35 that just shows that there's encryption in transit, meaning TLS certificate was used for intra and inter-cluster communication. And also for 37, this is just to state that you can communicate with Vault via APIs. So you can decide to use your Postman and make API calls to your Vault. So the next thing was to also initialize and unseal your Vault. Of course, if you create a new Vault, the first thing you do is initialize. And once you do that, you get your sealed keys. So in this case, we initialized Vault and we got 5 sealed keys. And then we stated that we wanted 3 minimum keys to be able to unseal the Vault at any point in time when the Vault is sealed. And after that, you unseal your Vault with those keys. And as you can see on the screen, on the right-hand side, you have a picture of the Vault being unsealed, and the state of the seal has changed to false. And the next thing, if you run the other clusters will communicate and election will take place, and they pick a leader. So if you run your Vault operator Raft list pair on any of the Vault node, actually, you get this information telling you which one is the leader and which other nodes are following. So after this, the next thing we did was now to bring in the MiniIO part of things. And I'm just going to allow Anu to talk about the MiniIO before we move to the demo. Anu, please, do you want to take us through the
Thank you so much, Razak, and that was insightful. So talking about the MiniIO part of things, like I mentioned earlier, you can set up your MiniIO in different ways. You can set it up as a container, as a systemd service, or any way you decide to go with. So right now we've set up our MiniIO, and we have also installed our MC clients, which is the MiniIO command line tool. So for us not to have to, define the URL, the keys at every time we want to run our MC, we decided to set up an alias. So that's why we have the MC alias set, my MiniIO command there. And after doing that, we have the MC alias list. That's listing the alias that we've set up. So like we mentioned earlier, the whole idea of this is for us to be able to create snapshots, push it to MiniIO, and recover it whenever we have to. So for creating our snapshot, the first thing we had to do was to create the backup directory. That's where we'll be storing our snapshots on the Vault nodes. So that's why we have the first make directory command. Then the next thing is to save our snapshots, just like we do with etcd on Kubernetes, for those of us that are familiar with Kubernetes. So we've done that. We've done our saving, and you can see we saved it to the directory we created earlier. And the last command is just us listing the the files in the directory we created. So yeah, then after that, I mean, the whole idea is to push to min.io. So this command is handling that for us. So this is us pushing the snapshots we created to min.io using the mccp command. So we'll be going to the min.io UI. So you can see the snapshots that we copied to min.io is right there on our screen. So yeah, then we have to restore from the snapshot. So the whole scenario is okay, your vault cluster went down, you have to set up a new cluster. So now to restore your snapshots from min.io, the first thing you have to do is to stop vault. As you can see, the systemctl stop vault command up there. Then we do a copy. We have to copy back our snapshots from min.io to our vault server as we have on the screen. Then we do a restore of our snapshots, and voila, we have our data back intact. So yeah, that's us starting vault. Right. So now, I mean, we all don't like doing things manually. Me, for one, I hate manual processes. I love to automate things. So that's why we decided to take this a step forward by automating the whole backup process. And to do this, we decided to set up a system D service that would run the backup scripts. And then we also decided to set up a system D timer unit, just like a cron job. So this is going to trigger the service based on the schedule we decided to set up. And the whole idea, yeah, the benefits, it's easily integrated with Vault. So let me just take us through the script we created quickly. Looking at our screen from line 5 to 13, that's pretty much us defining the necessary configurations for this script to work as expected. And then from line 28 to 41, sorry, that's where we check, because before you take a snapshot, you have to check if the node you are working with is active and if the node is the leader node, right? Because this script will be replicated across all the nodes on the cluster. So if you check the if statement on line 30, it checks if the HTTP code is 200, which means, okay, this node is actually active, right? And there's also another 429. It checks if the node is on standby. We have 503 to check if the vault is sealed or not initialized. So these are just different status codes that we decided to set up. Then to create the snapshots from line 43 to 53, this handles the snapshot creation. So I had to set up a timestamp. So I mean, if you want to recover, you can recover based on a particular time or date. So you can cover within a particular time and date. Then we have the snap time snap. We have the snap file. Then so line 43 to 53 handles the snapshot creation. Then from line 55 to 61, this compresses our snapshots because we don't want to send the snapshots to min.io the way it is. We have to compress it so we can easily move this to min.io. Then the idea at the end of the day, line 63 to 70 is us uploading to min.io. So we decided to take this a step further by creating a retention policy. You don't want to overflow your vault cluster. So with this, if the snapshot has passed a particular threshold, I mean, you can set a retention day. So when it passes that, it automatically deletes the snapshot file from your vault server. So taking us through the system D service creation, I mean, this is just showing us how we set up our system D service. We have the exec stats that points to the scripts, the backup scripts. We have the type 1 short, tells us that this should only be run. We also set the user, the group, that's for our privilege escalation. Then for the timer units, that's for the cron job, we decided to set it to run every 6 hours. As you can see, the on calendar that we set there, then the persistent is set to true. So if for any reason your cluster goes down, at the, your node goes down, at the time it comes back up, this script will always be triggered. So yeah, then for logs, I mean, if anything is happening, the first thing you want to do is to check logs. So the reason why we actually went with this system the timer service is because it automatically also sends your log to journalctl. So you can always run your journalctl command to scan through your log to figure out whatever is going on in case anything happens. So yeah, we've done a whole lot of talk, and I know for us in the tech space, we love to see things work. So we're moving to the demo time, and I'll be handing over to Razak to take us through this. Thank you very much. Razak,
All
over
right.
to you.
Thank you very much, Anu. That was a very, very thorough walkthrough. So now I'm going to be taking us through the demo just to demonstrate some of the things that we've spoken about. And we have our Vault cluster here running already. No secret is enabled. I'm just going to do a refresh. So I need to log in. I'm just going to quickly pick my token from here to log in. So you can see no secret has been created. And we also have our mini IO. As you can see, some backups has been taken. So the retention period, the timer for the backup was reduced to 2 hours. So we can see a very quick frequency of backup being taken. And you can see the time difference between these backups are just 2 hours. And so the first thing I'm going to be doing is to go to the CLI. This is the Vault 1, which is the leader node, but let's confirm that. So I can do my Vault operator raft list pairs. And this shows me that the Vault 1 is the leader node, and you have the other two following, right? So the next thing I can do now is to basically create a demo secret. So I can just pick a demo secret to create. So, but before I create the secret, I'm going to have to enable the KV secret. I'm creating the KV secret. So, so now I've enabled the KV secret on the part HashiCorp. And so the next thing is for me is to do my Vault secret list. Sorry, I'm switching between screens. So, oops. I think that should be secrets actually, Vault secret list. So you can see that my KV secret is enabled on the part HashiTalks. Okay. So I'm going to clear my screen now. So the next thing I'm going to do now is to create a demo secret. So I'm just going to pick that in order not to have to type all the commands. So now I can do this. So now I've created the secret. So if I go back to list my secrets, so I can also do like a Vault get secret to see if my secret was actually created. So I'll do Vault KV get, then the part where it was created, which is HashiTalks, and /app/config. And this returns my secret. It tells me I've created a secret, and this password is Vault123, the username is demo, and all of that. So if I go back to my UI as well, I should be able to see my secret. So if I do a refresh, it tells me to log in again. So I can do that. And you can see I have my secret created on the UI, HashiTalks, apps, config, and I go to secret. If I see, so this is the secret I created in the CLI, right? So what I'm going to do next is I'm going to take a quick backup of this secret. So I'm going to go back to my terminal and run the mini IO script that was created, the shell script that was created, I mean. So this is it right here, but I'm running it not on the master node. I'm running it on one of the leader nodes, and that's intentional. So you can see when I ran the script, it ran it up to the point where it's adding the mini IO again, but it didn't take the backup. So it means your script has to be run on the leader node. So if I come back to the leader node, I run the script. So you can see this did not only add mini IO, but of course it ran the script and also created the backup. So where was the backup stored? From the script Anu showed us earlier, you can find the backup in /opt vault, then backups. So I can just list the timestamp as well to see the last one that was created. So you can see right here, this one was created at around 10:47, which is just a minute ago on the 9th of October. And this is the snapshot we're going to recover from. But before that, I'm just going to delete every form of backup we have on this part, just so we don't have any. So I'm just going to delete anything that ends with .snap. Okay, so it means if we go back, we see we don't have, okay, so I'm just going to also delete the .gz snapshot as well. the one that is compressed. So if we list, we see we don't have any backup on this server anymore. So the next thing to do is, since we've taken our backup, I have to, and it has been pushed to Mini.io. So if we go back to Mini.io and just try to do a refresh to see, so you can see the backup was uploaded here at around 10:47, just like we saw on the CLI. So the next thing to do now is to delete this secret from Vault. So I can just easily come here and delete permanently. And not only will I delete it, I can also disable the secret completely. So I'm going to disable it completely so we don't have it anymore, right? So, and after that, the next thing I will do is just to simulate, like, okay, our Vault server crashed and now we created a new one. So we're trying to quickly revert to the last backup that was taken. So to do that, I'll go back to the terminal. And even if I run my Vault get secret command that I did earlier, but you can see it's returning an error to say this doesn't exist because it has been deleted. But of course, the first thing to do is to get the secret from Mini.io where I saved it. So I can easily do that by using our Mini.io command. So if I do Mini.io mcls and I try to go to my Mini.io bucket, so the alias we gave it is Mini.io and the name of the bucket is Vault. So it shows me all the secrets in Vault, but I want to pick the latest one, so which is the one of 10:47. So I can just copy that and do the name of the bucket is Vault and the name of the snapshot is this. So I can just highlight and copy it from here. Okay. And I'm just going to put it in /tmp. So you can see if I do go to my /tmp now, I should be able to find you can see I should be able to find my backup there. And as you can see, it's right here. So the next thing I'm going to do is to try to unzip it and then restore from that backup. So I can do the unzip command to unzip it. I have it here in TMP and Vault. Okay, so if I do this, it unzips it for me. As you can see, it's right here after unzipping. So it means I can do my Vault restore command to restore from this backup. So let's do that. So if I do my Vault restore, that should be Vault operator raft, restore snapshot. And what are we doing? We are restoring the snapshot and then the path of the snapshot, which is /tmp and the name of the snapshot. So if I run this command, it didn't give me an output. If you're familiar with CLI, you know when you don't get any output like this, it means your command ran successfully. So the first thing I'm going to do to test if I actually have my state back is just run the earlier command that gave me the secret I created. So I can run it in any of the other servers. Now I'm not going to run it on the master, but one of the followers and see. And look at that. Even on the second one, I have my secret back. I can also run it on the master node and it gives me my secret back. But that's not enough. I could also go to the UI and try to see if it gives me my secret as well. So if I go to secret, you can see I have my HashiTalks back. My secret is back and I have my secret back and my applications can connect and fetch secrets, and this can happen in actually no time, right? And something else that can be done in this to take it a bit further is also, if you like, automate the recovery process as well, just so it suits your needs, but that can be dependent on how your application was created. But the whole idea is to make sure that you have your secret management system, not only keeping your secret and make sure you don't have exposure of secret, but also having that system highly available so it doesn't go down and eventually giving you like a single point of failure. So going back, so what's the takeaway from everything we've said so far? You can build your highly available vaults with open source too. I mean, you don't have to spend anything to achieve it, and you can take advantage of the open source part of Vault and also the open source, the community edition of your Mini.io, and also Raft handles your availability, while Mini.io handles the resiliency part by storing the backup. The next thing is this is cost efficient. It is good for startups, for NGOs, for dev teams, and so on. And also it's a path to production readiness without having to commit to some extra licenses at first. I mean, even if you need licenses for some extra features, that could be in the future. But to start up, you don't need to spend so much. And the lesson learned is Raft is great and is simple, and you can achieve high availability with it. Like I said, simple things most of the time solve complex problems. And MiniIO provides you with the low-cost resiliency. You could even take offsite backup. And this can also, as we all know, MiniIO is compatible with S3. So you can even push your backups to S3, make it completely offsite. So even if your Vault cluster, if it was deployed on site, just saying, you can easily pull your backup and travel back in time. And another thing is the TLS certificate part of things, just to ensure that the intervault and the intravault communication is encrypted in transit. And also the domain name as well should also be implemented. It's critical just to ensure stability, and your cluster can easily join. And something else that can be achieved is putting a load balancer in front of all of your Vault instance, like an Nginx load balancer, and configuring it such that when you try to reach any of your vaults, your Nginx checks for the master node at that point before it forwards traffic to it. There's no limit to how creative you can be with this thing. And finally, system D timer is greater. In fact, I think the greater sign should come like 3 or 4 times way greater than cron job, because it's more integrated to Linux, so it runs like a traditional system D service in Linux. And you can also get your logs from journalctl, like Arno said the other time. That's all we have for you today. And if you want to do like a step-by-step of everything we've said, you might have rushed a few things or not touch on some things clearly. But if you want a step-by-step on what we've done, so you can just scan this QR code. It takes you to a blog where you can follow everything we've done step-by-step and duplicate it in your environment. Thank you very much for having us today. And I hope we've been able to share something meaningful and reasonable with you. Thank you.
Within that time, I offer support.
Yeah. Okay, right. All right. So thank you, Abdurrasaq and Ajase. That was really insightful. Really enjoyed seeing how snapshots are taken with MinIO. So that was good. I can't wait to try it out myself. Before we move on to the next topic or next speaker, we have an announcement to make, which is for the user group. The Hub program spans the world in 65 countries with over 59,000 HashiCorp users across 190 chapters. So there are 14 Hub chapters in Africa, and we want you to join. So visit hashicorp.co/hugs to find a chapter near you or to learn how to start your own. So also, Celestina, our next speaker, she is an amazing hardcore organizer in Ibadan. So anybody interested, reach out to her. With that being said, oh, Patrick is back. Patrick, do you have any comments before we move on to Celestina?
All good. I just wanted to say that I've really enjoyed the past session about automating Vault, and I'm really looking forward to trying it out myself. And yes, we can now move on to the next speaker. Thank you.
All right. So we have Celestina next. He's going to be talking to us about golden images made simple. So automating infrastructure with HashiCorp Packer and HCP Packer registry. Thank you.
Hi everyone. I'm really hoping I am audible. Okay.
Yes, you are.
Okay, hi everyone. I'm super excited to be here again. I am Celestina, and like the introduction said, the organizer of HashiCorp User Group Ibadan. So if you are from Ibadan and you're listening to this, please join us. We do amazing stuff, and it would be lovely to have more people. So for today, I'll be talking on imaging, like golden image. You could call it hardened image with the use of Packer and HCP registry. So let's just go into it. What does HCP registry do for us? So I've heard when I have conversation with people and they're like, oh, they don't really need the registry because the cloud platform they are using to host the image already have the information they need, and that's all. But there's an additional advantage that this provides for them. It provides a central place where metadata for images can be stored. So it doesn't matter if it is GCP, it doesn't matter if it is Azure, AWS, like, right? It's how you have like a single dashboard where you can just check everything that you have, who made changes, right? And how did it come about? The tracking, if you want to check the image that has been made over time, you want to move it to a different environment to be used, right? That's where HCP come into. Now, Packer. What does Packer do for teams? So I would love to say Packer is like having a Docker image, but for VMs. So Docker image are like for containers, but you need like an OS image that you'd use to set up your Ubuntu server or whatever it is, right? So that's where Packer comes in. So you don't want to do the hard work of installing everything, then taking a snapshot of it, which is like a way people do it, but like Packer makes it easier for you, right? And you have like a reliable image. Say you have like a security team that says on every image there should be a kind of agent that is running, a security agent that is running to maybe scrape when changes are made to a file, maybe script when a vulnerability, you could have Trivy running on it, right? And you want it to be on every image that is used within the organization. So it gives a sense of consistency along everything you're using along the image, right? So that's for Packer, what it does. So now, okay, I think I already mentioned something about the multi-cloud, how you can use it to build images, how it helps you to set up if you have it could be internal applications that you are building, right? And you want it to be that every image that comes up with this, or every VM that is created rather with this image, are with the setup that you've provisioned, and you are sure, because human beings are prone to make errors, right? If you assume that, okay, yes, there's a step somewhere, people are supposed to follow it every time they set up an instance, they're supposed to run an update to update the pack or settings that is on it, and someone makes mistake, so you are exposing yourself or the company to attacks, right? So but if there's like a single way where every image, you are sure that every image that is coming, that is being used are already hardened, you set up your tools, everything is on it, it makes it easy to use. So for our demo purpose, I'm not really going to go into a lot of setting up the security tools, right? I would want to use a portfolio. So the whole idea would be that this portfolio app could be an app, it could be an agent, it could be an internal service that the security team has developed, or a dev has developed, right? So it could not be this app that I am using as portfolio would now be hardened into the Packer image, right? So when it is into, so meaning any image, any VM you are setting up with this Packer image would have this portfolio ready and running. So you don't have to go into the image and start setting up any changes or start setting up anything whatsoever. So I'm not sure why my arrow is not working, but we'll just move. So now I put a simple code here that we could just go through, but we'll see the main scripts and codes in the demo time. So for this place, you see here the Packer registry, we have like a bucket where it is going to, so this is like a variable, it would pick it there. Then we have this label. So now I was mentioning something about this when I said something that is good for audit. You know what is what, who owns it, and who provisioned it, at what time, which image, informations about the bucket, about the build could be added to this as extra information and whatnot. So yeah, I know I didn't include Terraform in this, but in the title, but Terraform is also part of it, right? Because Terraform would help us set up the image with a VM, in a VM, after we've created the image and whatnot, right? So this is how it will use it and whatnot. So let me move, then demo, not too much talk. So before we get into the demo, I want to show us like what we may need to do before that. So I have here my HCP. Hoping it is visible and does not log me. Oh, logged me out. I was trying to refresh this multiple times so it does not log me out, but well, here we are. Okay, I'm hoping it comes on soon. Okay, so we would be needing client ID and client secrets for this our setup. And how do you get that, right? Where you have set up your HashiCorp registry account, right? Or HCP account, you want to come to this access control. So you go there. Okay. Then I have created one, but I just want to, sorry, this is supposed to go to service. I am really hoping my arrow is showing. I am really hoping. Okay, so the service principal, then you create one. I will just create one that will delete, right? But just so we see what I'm doing. So for now, we want to make it to be a contributor, because that's like what can create and delete image and add buckets and whatnot, right? So after creating this, you create the service principal. Now, I have created this. The next thing you want to do is keys. Okay, I will delete this key, but I just want to show you. Go to generate. It will generate a key, right? So I will delete this one because I do not need this. Okay, so that's how we get that one. I just wanted to show us briefly how we get down. Then here I went into Packer. I already have, like, I did this one when I was trying to set up the image, this demo, and this is the current bucket I'm using. And please note that the code I would be sharing later creates the bucket for you, sets up everything for you, right? So we can as well delete it and start all over again. But let's just move on so we don't waste so much time. So now we have our channel, we have our bucket, we have everything. We now move on to the code. Okay. And yes, so we'll be using GCP. Before I move to the code, we'll be using GCP. This is my current cloud environment. I have no instance running, nothing is here, but we'll have one running after this demo, and that we can use to access our resource. So next thing is, please give me a moment. Let me share my code. Okay. All right. So we are here now, right? So let me make this smaller so we can have like an overview of what it looks like. So I mentioned that we'd be using like my portfolio, which was something that was created like I think a while ago, right? So it has, let's say, Dockerfile, some informations about me, certifications that I have done. You get. So now after this, then we now have our Packer. Now coming here, when you look at this auto says you don't need to put that the flags to be able to pick up the variable, right? So if you are familiar with Terraform and you're familiar with TF-vars, so TF-vars is coming in place of this PKR vars in Packer, right? And I just put in this here. So don't mind that I am exposing all these things. It's not really something serious. They are what I use for demo sessions most time. So you'd update this to your own project ID. So this would be GCP. This would be your applications that you'd be the setting up that you'll be putting rather. So your zone, your region, the kind of image you want to use, you set up everything, right? So like I said, if I should change this one now to 1, it would update it and create it for us. Then here is, this is a local file. So it would help us set the image in the sense that we want it to have like a tag, a time stamp, something attached to them, right? Then the next thing would be our source. So before we get to this source, let me go to this place. So before we explain now, the Packer is using a plugin. So plugin is more or less like so I'm trying to relate this to Terraform because I feel like a lot of people are more familiar with Terraform. So in the same place you have like your providers plugin, your you could have like AWS, you even have like SoundCloud, right? Your provider GCP that would help you provide these resources that can help you connect to it, because we are familiar that Terraform just gives you the shell, then the plugin are the extra information that would help you connect to the resources you want to reach, right? So it's the same way Packer works, right? It gives you the shell, then these plugins are now what connects with it. So in this plugin, if I was working with let's say Azure and GCP and AWS the same time, I would have everything listed here with just comma, just like, moving forward, adding it, and then putting everything I need. But this is just all I need. So this now would be what would be used in this place, right? That is what you see here as source. So we give it a name. This name is just local to what I am doing. It's not really super particular to, I could have named it portfolio, I could have named it anything. So here is picking up that variable that we set here, right? Then the next thing, so this is a default for Packer for the image ID that used to connect to Google Cloud and work with image. So the zones are what are already in the PK vars, right? The zone, the image. This is like something that will tell you, okay, you are doing this, the SSH key, everything. So tags, no, so tags now is more particular to Packer. There are 2 tags in this instance. So there's a tag of there's a tag on GCP. Then there's also like tags and labels on what is it called now? Pack on AHCP, right? So this now would help us connect to the instance that we are setting up, right, on GCP side. So now the next thing we want to do is the build image. So this is also like a name, right, that we just gave it. And what source would you be using to be using this? What do we want it to do? We want it to set up these buckets, add all these labels that I showed in the slides. After the setup, then this would be like, it would wait. It would not run any sort of provisioner. So provisioners are what would go to how Packer works. It first provisions like a shell server for you, right? That server would not be where everything would be run. Maybe you want it to copy a file, you want it to add a file, you want it to set up some additional things, it will do that. So in this shell now, we have inline. I also have one of file. So for this inline, for this shell of inline now, it's telling it to, when the image is provisioned, or the Packer image is provisioned first, it will tell it to wait, that don't run any other provisioner until the instance is up, right? Then the next thing we want to do is to make this directory and copy it. So we are copying, make this directory and then change the owner. So it should be Packer, because it's Packer that we are using as the SSH, right, as the user. Then yeah, so here it would make, copy, And then, oh, I was supposed to move this upward. Sorry, I was wondering how I scattered it. Okay, so this is not supposed to let me just rearrange it for my sanity's sake. Okay, so this is supposed to make this folder change the ownership, then copy this folder that I have here. Remember this folder that I have here? So that is why I said it could be anything, right? That the company or you are testing out and you want to add it to all the images that you are provisioning, right? It copies this and adds it to this part on the VM, right? Then the next thing is it would run this script. So I would show us the script and what it does, right? So in other words, this script would create a Docker. This script will install Docker for us, set up dependencies that would need to run Docker, and then this script would now deploy the image and set up system D that the Docker image would be using to run going. Then this would just be, clean up extra files that have been created during setup and whatnot. I think I missed one where it would okay, no, it's here. Okay, so plugin, I've explained plugin. Variables are just variables that we listed here. So the next thing now is the script. So the script is, the first one I mentioned is this install Docker. What is that? This is just a simple bash script that installs the dependency of Docker and then set it up. If you've installed Docker before, right, you realize that you have to go through a list of some things that would help you set it up, install it, and then if the VM does not have it before, that's like a whole process that you want to be doing every time you are setting up Docker. And this is something that this image already has, right? You don't even need it again. You just have to spin up the image and then you have Docker running on it, right? It's set up. So all these are just configurations that it will use to set up Docker image. Then this one is setting up the system D that the portfolio app would be using, right? So it's a simple Docker system D that was created. So I was trying to test this out. So so let me start from the TFVARs. So here is also adding, the image, family, extra informations, network tags. This is what GCP used to be able to connect if you do not add it, except you want that's more GCP specific anyways. So the variables are what you put. Then here the main here. So now this is where HCP now comes in now. So you see, it's saying data is saying, what do you want to pull? What are you pulling from? It's pulling from here, it's pulling from the image, what we already deployed to HCP. You see everything we have here, the names are here, right? It would pick them up. Then once it picks them up, so since we're just doing a simple demo, it's just the firewall rule and just the VMs are just one VM and firewall rule, so we can access it is what was set up. Then this, then this we don't really need this because it's not does not have HTTPS. Then every other thing are just compute instance. We're setting it up, we're telling it to pick this data from here. If this one is not available, pick this one of them to pick it, and it will work. So when it's done setting up, it will generate an output for us. That's the IP of the instance and the URL. So you can just click from here and get to it. Okay, so that's the explanation. So now I will just run my stuff and then I'll see. Okay. I'm hoping I'm still visible. All right. So the first thing we want to do is want to initiate this, want to initialize it, and then we'll do Packer init because this is our folder. Right, so let me close this so it's easy. And by the way, I have a lot this information written on the README, so you have something you can follow after now, right? So after this, We've done the initialization. Then the next thing you want to do is you want to validate. Oh, sorry. You want to validate if what we have so far is good, right? If it's not good, it would throw error on lines where you can check and whatnot. So the next thing we want to do is now want to build the image. So this will take a little bit of time, but I am really hoping it does not take that much time, because the time it takes here also depend on the configurations you've added, like the steps you've added here, what you've told it to do, informations you've provided for it. All these are what it would now be doing, right? So, but since we don't really have a lot, we just have like I think about like 3, 4, 5, yeah, 5 provisionals, or 6 rather. So it's not really going to take so much time. So it has started. If I go to GCP now, I would have I'll have an instance that is currently running temporarily, but let us wait for this to complete and then we'll move on. It's taking a while. All right, that's connected. So let me see if I can make this thing bigger. Hoping I do not spoil this. I'll just leave it like this. All right, so I would love to check here. So in this place, yeah, I think I missed it here when I was explaining. So in the install Docker, right, we want it to update to run sudo apt update. We want it to do this. All those information we put here are what would be running. So you see here is running the sudo apt update. Once it's done with the update, it would move on to the next. You see it is installing this sudo apt install CA certificates and whatnot. Everything that is here is running that. Once it's done with that, the next thing we told you to do is to run this command, which is what is running here. So in other words, everything we list here is what Packer would now follow, right? We've done some configurations. It will then pick it up, right? And then once it's done again, we told it to run an update again and still proceed. So it is still running, setting up the changes that it needs to do, and everything is going fine. So let me just scroll down a bit because we're going. Oh, it has moved on to the second line of this. Okay. The first line that ran was this. Where is it? Okay, the first line that ran was this deploy portfolio is now what is here. So if we should go into the script, right, you see this copying, doing the Docker build that is what is happening here. And building the Docker image keeps moving, getting the layers. Then the next thing we tell you to do is to provision shell. It's doing that also. Okay, that's even finished. That was so fast. Excuse me. Okay, so once you see this deleting images, like at the background, it is trying to capture the current state of that image, right, and save it. So once we're done with this, I would get the IP, then we can move. Okay, it is creating the image. Take a little bit of time, so to be up in like, let's say 2-3 minutes. I wanted to do this live so you see how long it takes, and some would be longer than this because the whole process that is happening here is everything that I've input. So if I had more information out here, it would take that also. So now our image has been created. You see it here. So this is what we have. It has been stored here. This is the image. This is the image. See that here? I'm trying to see if I can make it wider. Okay, so this is the image, right? And it's currently stored here. So the next thing we now want to do now is to do Terraform, right? Because we already have an image. Now, how do we use that image without necessarily setting up a lot of things, right? So next thing would be to initialize our Terraform. Once we initialize it, we could do a Terraform plan, right? So since it's the right thing to do, so see what would change the provision. So you see 3, I mentioned just firewall and then the VMs. The VM would be using, then the next thing would be, please do not do auto approve on production because I just did that so we do not waste so much of our time. So this should finish building. Once this is built, we would get an IP that we can now check. Okay. Okay, so now we have all this set up now. So we have like a direct link straight to the VM or the instance that was created on GCP. We have the IP. So I'll just copy this right now and then go off a bit so I can reshare my Chrome browser. Okay. All right, so remember what we had here, right? So now if we do a refresh, we now have a portfolio VM that is running, right? So we could now put the IP. So it should bring us here. So this is me, right? This is running on the server, nothing too fancy here. So now let us see what we have on the instance. So I want to SSH into the instance. So we'll see what we have on that instance, right? I'm just doing this authorize. Okay, so oh, no, do Control L. All right. So remember we set up a system D for this. So we want to check if that service that we set up is running, right? So we see it's running. Want to go back, want to cancel this rather. Then let's do a journal CTL to see the logs we currently have. So it's showing the people that are accessing because it's just me. So if anyone tries to access this IP right now, you would be able to see same thing I'm seeing because I opened it to everyone really. So it's not super secret stuff. So then you do docker ps. Oh, sorry, sudo docker. So it has that running. So it means that you could have anything you want set up there, right? So let me just show us one thing. So in case we do the setup, we do not make mistakes and leave that running. So now I want to go and destroy what we've created. So do not have them I'm just running there since it's just for demo purpose. So you just run your, let me do this, like it to be up. So you just run this, then put it in, so to destroy the environment. Like I said, it's just for demo, so you don't get build and at the same time be able to get the knowledge you need. So now while this is getting deleted, I'll go back to my slide and continue so we can round up in a jiffy. Okay. All right. So what we did here was to automate the image, manage, promote the build, and integrate with Terraform. There was no point in time where we had to like start manually changing it on Terraform after building. So it means that a different set of team can be in charge of building, while they know that okay, everything they are building is secure and whatnot, while they are sure of that, and then a different set of team are the one using it. So that way they will say, okay, we are missing some information and one thing. So everything is up to date, and there. So like docs, you can use resources. There's a Packer documentation, the registry, and the Terraform guide. And yes, so I have the GitHub link. You could just check here. Once you scan it, you get directed to the GitHub link. And this is my LinkedIn in case you want to say hi. I am always fun to talk to. So that would be all. It's been really fun doing this again. Thank you, everyone. See you next time.
Thank you, Celestina. That was very insightful. I personally like using HTTP Packer for managing images within my Terraform code, so it was really good seeing what you've done. Patrick.
Yes, Wale. Hi.
Yeah. Do you have any insights or any comments?
Yeah, it was really interesting to see how she was able to show us how to combine Packer with Terraform. I'm really looking forward to trying it out. I think that was really awesome. And thank you again, Celestina, for that awesome presentation. And also thank you for being benevolent enough to give us the link to the repo where we can now get to try it out ourselves. So thank you, everybody. Should I read the announcement or you want to read it?
You can carry on. That's fine.
Awesome. So we have an announcement for all of us. Just remember that we will be sharing all of these talks on YouTube in the coming weeks. So if you're just tuning in, you can catch up later. You will not have missed anything, and we hope that you will go on and try out these awesome presentations or awesome products. Thank you. Wale.
All right, awesome, thank you. So we have our next speaker, Samuel, and his talk is about, can you terraform your way out of a misconfigured nightmare? We'll find out. All right, take it away, Samuel.
Good evening, everyone. So my name is Samuel Masharia, and I'm a cloud engineer, also a Microsoft Cloud Student Ambassador. This session is brought to you by HashiTalks Africa, also supported by the Microsoft Cloud Student Ambassador program. And the title of my session is, can you terraform your way out of a misconfigured nightmare? So the presentation introduces the reality that infrastructure as code can both empower and endanger teams when used without discipline. So you see, Azure's cloud ecosystem offers vast capabilities, but its complexity means small misconfigurations can cascade into major production outages. So the goal is to highlight how Terraform combined with alternative tools how they can be a hero or a hazard, depending on how they are wielded. So as we explore this topic, the emphasis is not just on fixing issues, but on building that resilience that teams want. So misconfigurations are inevitable, but recovery and prevention strategies separate mature DevOps practices from the reactive firefighting. So this session will explore how to move from chaos to confidence when managing Azure infrastructure at scale. So this slide is focusing on infrastructure as code as the problem and also as a solution. So IAC enables speed, repeatability, and automation, but it also introduces risks which teams can treat code like configuration scripts instead of software assets. So broken module dependencies, poor secret management, or pipeline missteps can cripple the entire environment. So whether you are in the development or production environment, so IAC magnifies both good and bad practices. So when applied with structure and governance, Terraform can transform chaos into order through version control, automated testing, and recovery workflows. So however, without these guardrails, IAC becomes a sharp weapon that can cut the very teams wielding it. So recognizing both sides of the sword is the first step towards mastering everything about IAC. So Azure deployments often fail in predictable but painful ways. So circular module dependencies, locked state files, and hard-coded secrets and pipeline breakdowns. So these issues don't just stop deployments, they also create inconsistencies across environments that lead to costly production incidents. So by studying these failure patterns, engineers can design a better preventive measures. So the key takeaway is that Azure's scale demands strong dependency management, secrets handling via Azure Key Vault. Actually, I did give a talk at PyCon Kenya last week, but one on Azure Key Vault, and also CI/CD hygiene. So recognizing these patterns early turns painful debugging sessions into valuable lessons for future stability. So I'm also going to do a live demo representing a realistic Azure outage scenario where Terraform deployments fail mid-process. So using Azure Resource Graph and Terraform logs, we'll pinpoint the root cause, assess the scope of the problem, and carefully implement remediation strategies without worsening the issue. So the focus is not just technical recovery, but a procedural discipline, that is how to pause, analyze, and communicate clearly during incidents. So true recovery involves balancing urgency with precision, ensuring that while you fix one problem, you don't introduce 3 new ones. So the key Azure native tools that are mostly used by developers and also cloud engineers for recovery include the resource graph, a Key Vault, and also the bicep. You can feel free to take a screenshot of this. But Azure does provide powerful built-in tools to complement Terraform recovery workflows. So starting with the resource graph, it enables the querying all resources at scale, revealing drift, dependencies, and orphaned assets. For the Key Vault, it centralizes that management of secrets for your application, reducing the risks associated with hard-coded credentials or mismanaged certificates. Then additionally, the last bit about Biceps. Bicep is a new tool in town. It provides an Azure native IAC approach that can be used alongside Terraform for emergency interventions. So when Terraform state is inaccessible or corrupted, Bicep can help restore resources or validate configurations during Azure's control plane. So combining these tools creates a multi-layered recovery strategy for cloud developers and also cloud engineers. So let's focus now on module refactoring strategies. So first, there's breaking circular dependencies. So refactoring Terraform modules is crucial for scalability and maintainability. So breaking circular dependencies enforces version pinning and building atomic modules, ensuring that each piece of infrastructure can evolve independently. So this separation of concerns simplifies troubleshooting and encourages that modular thinking for system engineers. So comprehensive testing, both unit and integration testing, turns module development into an engineering discipline that, rather than the trial and error deployment process for discipline in engineering. So these strategies prevent cascading failures, enabling teams to deploy confidently and refactor fearlessly as infrastructure grows. So let's now shift gears to cover state file hygiene-based practices. So Terraform's state file is a single source of truth for your infrastructure, making its protection non-negotiable. So for remote backends, for those who have used remote backends to deploy their resources to Terraform Cloud, with proper state locking, encryption, and access controls, they do prevent corruption and unauthorized modifications. Regular automated backups provide a safety net when accidents occur. So a corrupted state file at 2 a.m. is a painful but a powerful teacher. Treating the state file like production data that is secured, monitored, and backed up turns potential disasters into manageable recovery exercises. So these are some of the habits that I thought it wise to highlight to distinguish mature DevOps cultures from those constantly firefighting. So the focus on this slide is on how to build self-healing infrastructure. So a true DevOps ecosystem doesn't just recover, it heals itself. So self-healing infrastructure relies on constantly monitoring, drift detection, and also automated remediation scripts triggered by anomalies. So what do I mean by this? So when combining with machine learning, these systems can predict failures before they happen. So by embedding resilience directly into infrastructure designs, teams reduce downtime and also the fatigue that comes from performing operations. So instead of relying on engineers to fix every issue manually, self-healing systems empower automation to handle known problems, freeing engineers to focus on innovation. So in my journey in cloud development, these are some of the hard-learned lessons that I thought of capturing in this slide. So the first one is about using a Terraform for version controlling. Then the second bit is about testing production-like environments. Then lastly, how to plan for cross-cloud portability. So for every configuration, it always does leave a lesson. So version controlling everything from Terraform code to documentation and pipelines creates a transparent audit trail that simplifies debugging. And testing in production-like environments ensures surprises are discovered early, not during high-stakes deployments. Then lastly, about the cross-cloud portability, it's another hard-earned insight. Designing modules with abstraction layers allows for flexibility across not only Azure, but also AWS and GCP. And these practices prepare organizations for the future while strengthening the current operations. Then lastly, this is your Terraform Survival Toolkit, which just serves as a takeaway for the session before we dive into the demo. So a Terraform Survival Toolkit balances prevention, recovery, and resilience. Prevention involves automated tests, drift detection, and configuration validation to catch errors before they deploy. Recovery focuses on restoration, simply rolling back, importing resources, and fixing state inconsistencies quickly. So resilience, which is the final phase, ensures infrastructure can understand chaos through redundancy, failover, and self-healing mechanisms. So the ultimate goal is to evolve Terraform practices from reactive scripts into an intelligent, autonomous ecosystem capable of driving and also thriving amid cloud complexity. So let's now shift gears to my simple demo. Let me stop sharing my screen, then share my VS Code. Nice. So I want to share the entire screen, then dive straight into my demo. Here it is. So this is my demo. I named it Terraform demo. It has 3 files. That is the main.tf file, then outputs for the output for my configurations, then the variables that I have defined. I have only defined the location for my configurations. So when we take a look at the main.tf file, it only has the definitions for my provider. So I'm telling Terraform that I want the Azure provider to deploy my resources. And as you can see, I've also defined my Azure resource group. Then I want to create a storage account. Then I've done an intentional misconfiguration for my storage account, given it just 2 letters for my name. But by default, what is required of me is 3 to 24 lowercase letters or numbers. So the first thing that I need to do is to tell my Terraform to start initializing, of which I've already done that using the Terraform init as the first command, as you can see here. Then after that, I need to do the Terraform plan, which is basically me telling Terraform to lay out a plan for me to see the resources that I want to deploy or to procure from Azure. So this is the error that I get, a simple demonstration of how I can get a misconfiguration. And after that, what do I need to do to correct this error? I need to add some few more lowercase letters or numbers just to make sure that they are unique. Then after that, I can use the same command, Terraform plan. And let's see if this is going to solve our problem. Terraform plan. It's taking its sweet time to give us the plan. And it's going to acquire the state log. So we need to save our file again just to make sure that the updates have been picked. Then do a Terraform plan. Let's pray that the demo gods work in our favor. Waiting for the plan to be displayed. Can try opening another terminal. Another process has locked a portion of the file. So we go back to the initial terminal. Yes, it is still running. And boom, it's working fine. So as you can see from the output here, we have already created the storage account now without the error. getting all the green check marks confirming that our storage account will be created with a new name. And the last command will be the Terraform apply. So this is the output that we get for our storage account name that we have just entered. So this is just a simple demonstration of how we can solve the problems that we face in Terraform and also fix them with the simple solutions that we have just made changes in our main.tf file. So thank you everyone for joining my session, and in case you have any question, feel free to reach out to me via LinkedIn, also on Twitter. I'm also free to guide any one of you regarding passing any of the Microsoft Learn certification exams. So yes, and also thank you to the HashiTalks Africa team for accepting my talk, and also the Microsoft Learn Student Ambassador Program team for supporting this session. So till next time, adios.
Thanks, Samuel. That was really good. I definitely agree. Always having documentation is very useful. Before we move on to the next speaker, Patrick, do you want to have anything? Do you have anything to say regarding what we just watched?
Again, thank you, Sam. Thank you, Sam. Thank you, Ale, for this opportunity. So that was really eye-opening, and I think going just through that presentation, it brings to the fore the fact that using a cloud agnostic tool like Terraform for your workloads really helps. And it's actually good that he has shown us how to use it in a specific cloud. I believe he showed us Azure. I'm yet to use it on Azure, but I've used it on GCP and also on AWS. So that was really nice. And again, thank you for your benevolence, and thank you for offering to guide people who are interested to learn more about this stuff. So thank you so much, and we are looking forward to having you again in the future. Thank you, Ale.
Thank you. So our next speaker is Abdul Halim, and the talk is about multi-stage cloud run deployments with Terraform and Google Cloud Deploy. Thank you.
Hello everyone, how's it going? I hope you all are having a wonderful day. My name is Ali Moseni. I'm a software engineer with over 5 years of experience building and deploying both web and desktop applications. I currently work as a software engineer at Memco, where my team and I build software for metering solutions. You can find me on LinkedIn at Hosseini Abdullahi. So in today's session, we'll be talking about how to set up a multi-stage cloud deployment with Terraform and Google Cloud Deployment. So basically, Terraform will handle basically declaratively defining how we want our infrastructure to be set up, what goes on Google Cloud. It will handle the setting up of the artifact registry, the cloud build connection to GitHub, which is the application repo we'll be using. So also handle these some other things like the service account, and we'll talk more on that in the infrastructure record. Then for the Google Cloud Deploy, this basically allows us to manage the pipeline. So it will allow us to control deployment to the delivery to the production. So let me show you an overview of how the cloud deploy looks like. So this is basically what we're trying to do today. We are basically trying to show you stages how you can create a multi-stage view to production. So this is the testing stage, this is the staging stage, the staging release, and this is the production release. So every time we are making a commit, a release is being created for each stage. So in this case now we have the testing release, which is based on the commit and hash. If you look closely, this is the last commit hash. So as the release is based on the commit hash. So every time we are making a commit, a new release can be created. So what are the agendas for today? We'll be talking about why do we need a multi-stage deployment. Then I'll look into the architecture and setup of how I implemented this workflow. Then I'll also look into the infrastructure and the application repo, where I'll show you how I implemented things in the background. Then I'll also talk about the challenges I faced and how I solved most of it. Then we'll do a practical session where I show you how everything works underneath and all. Then we'll conclude with some key takeaways. So why do we need a multi-stage deployment? For example, now a developer in your organization, right? Once he completes a feature he was asked to release and he is ready to test, right? He can't deploy to the production directly, right? You want to test personally. At the same time, we will also want to share the URL to other members of the team in the organization. Let's say the Q&A team or some other teams in the organization that will need the URL, right? So if we want to set up a multi-stage build where for each verification and you've concluded that everything is working perfectly well, they can then deploy to production, right? So this is where multi-stage deployment comes in. So we are saying, okay, immediately the developer pushes whatever changes he makes to the code base, immediately he or she pushes it to GitHub. GitHub, a cloud build runs in the background, then handles everything from the containerization to deploying it to artifact registry. In the artifact registry, cloud deploy release uses it to create a release test. So a release test for the developer to see and test his own changes. Once the developer verifies that everything is working perfectly well, he can then promote it. He can then promote it to the staging part. This staging part is where the Q&A team can now test it on their own to see what changes were made, if they would like for more changes to be made and all. Then once everything is verified, they can then move on to production where we have the live customer traffic and real users. It is also stable. And one thing I really love about Cloud Deploy is it has this rollout feature where you can roll out to your previous release, which is based on the commit hash. If something breaks and you want to roll out to the previous release, Cloud Deploy has that feature. So the architecture and setup. So for me, I was able to implement this multi-stage cloud deployment was I created an application repo for the developers to actually see what is going on underneath and whatever changes they are making in the code base, this is where it is going, the application repo. So what are in the application repo, right? In the application repo, we have a Docker file. This Docker file handles the instruction to containerize our application. So once everything has been containerized, we have the cloud builder YAML file. So let me show you an in-depth view into the application repo. So the application repo is basically what the developers work on, right? So if you look into the application repo, we have the Docker file. This basically deals with the setup instruction of how our app should be containerized. Then within that Docker file, we have a cloud builder YAML file. Cloud builder YAML file basically instructs it and says, oh, okay, this is how we want the build to be done. Once the build is done, we want it pushed to an artifact registry. Then that artifact registry, by the way, is already set up by the infrastructure repo. This is where we have Terraform setting things on. So then once the image has been deployed to artifact registry, Cloud Deploy creates a release into the testing environment to undo the necessary things. And also I'm storing logs in the Google Cloud is one of the logs by using this value, default log here. So moving on. So that's an overview of everything in the application folder. But there's one thing I want to show you, the application folder, basically the thing that handles the deployment to Cloud Deploy. So if you look at the Cloud Deploy, remember earlier I showed you how the pipeline is. We have the test, staging, and the production inside the serial pipeline. This is where everything is handled. So the Cloud Deploy, we give it an instruction now. Okay, once they release everything to be deployed to Cloud, then we have three profiles, right? We have the test profile, staging profile, and production profile. This is where we are doing further customization of the instruction we want it to give. Then if you go into the customize based on this, customize overlays production, this is where we set the instruction that you should add a suffix. So basically we are saying that you should add a suffix to the name in the base. So production, right? For production file. If you go back to the base, if you go into the base, you notice that the name is Mahal. So it basically adds production to the end of Mahal. For test, it will add test to the end of Mahal. So if you go back to the cloud run section, and I'll show you what happened. So it is deploying whatever build is making, and it is adding basically a suffix based on the environment it is being deployed to. So for production, it got the suffix of map, production, staging, map, staging, likewise for test. So that's an overview of what happens in the application repo. Moving on to the infrastructure repo. Infrastructure repo basically contains the instruction to set up the resources on Google Cloud, right? So Terraform handles setting up the artifact registry, cloud build trigger, and some other important things in infra repo. Then if you look at the GitHub Actions, the GitHub Actions is basically what handles applying whatever instruction we make to Google Cloud the moment we are pushing into that repo. I'll discuss more on that in the next slides. So let's see it in action, right? So we have let's walk through the application repo first. So basically, the moment a developer is making changes, right, and he has made the necessary changes and he pushes to the GitHub. Let me walk you through how that can be done. So we're going to the application repo now. So, okay, let me check the branch I'm in. Perfect. So I'm inside the application repo now. I'm going to make some changes into code base so you can see how things are working out. So you notice that currently we are cloud engineer. Let's call it a software developer. We change that to a software developer. So previously it was a cloud engineer, so we changed it to a software developer. Let's change it at the top to a software developer. You notice, so you change it from engineer to developer. So I want to walk you through the process that happens when we make changes to the application. So I'll add a thing I just added. So commit and title. Push. So okay. So I made a restriction on the repo such that you can't push directly to me. A pull request has to be made. So we say origin. So if I go over to the application repo, let me show you the application repo. So you notice that I've made a pull request. You can't push directly to me. So a pull request has to be made. Then what is it approved? It can be merged to the branch. So we say change title for so then we can say fetch pull request. Once everything is done, some text goes on. Also, I also deployed it on Vercel. That's why Vercel is showing here. So, okay, next request for for item. So the moment a push is being made into the application repo by the developer and it is merged, and the moment it immediately goes to the main, the cloud build is triggered, right? So the cloud build is triggered. So basically, the cloud build does the building process. That means that it is containerizing our application and it is deploying it to the artifact registry. So pending anytime it builds, let me walk you through what goes on in the application, the infrastructure repo. Go through my slides now. Make sure what happens in the infrastructure repo. Basically, what happens in the infrastructure repo is whenever they develop the team handling the infrastructure, whenever they make a push into the infrastructure repo, We have GitHub Actions, impersonating a service account with the workload identity federation, which is like that allows the workload identity federation basically allows you to impersonate a service account for a short period of time. So if you impersonate a service account, then it deploys whatever instruction we've set in our Terraform files. So basically, let me show you what we have currently in our Terraform file. So if you go out to our Terraform folder now, so this is where the infrastructure, everything else in the infrastructure. So let me walk you through what goes. So basically, for us to create a build trigger on the application repo, we need a personal access token from that organization. So the moment we get that personal access token, we add it to the secret manager. We create a secret manager and we add it to the secret manager, basically. Once we've done that, based on that, we can now create a Cloud V2 connection to that repo. So this is where the connection is happening. So we use the secret personal asset token from that GitHub organization to create a connection to the application repo. Once we are done with that, we can add our GitHub route, this is the application GitHub and repo. And once everything is done, we can now set an instruction that a trigger should be made anytime a push is made into the main branch. Remember, you should run the cloud build on YAML file. So that was why you saw that build going on earlier on. Remember the build that was going on was immediately I pushed into the repo. So that's where the instruction is coming from. So the build is still going on. So basically, this is where what handles that build process. And we also have some other things in the infrastructure repo. For example, we have what sets up those deploy profiles. Then basically that release pipeline. So this we look at deploy target for the test part of the pipeline. Then we notice that it does not require approval, so you can just a release can be made immediately to that place. Then we have the staging. This requires an approval before it can be moved into staging. Then we also have the production part. So this also requires an approval before it can be promoted to production. So that was basically an overview of what goes on in the infrastructure repo. We also have the service account and other things that are handling the cloud view. Something else I need to show you. Basically, so this is where the authentication is happening. GitHub action service account using the local authenticator. And after once it has impersonated it, it is able to apply necessary Gmail. Then installing the backend on Google Cloud Storage, I have a bucket here that handles everything. So another member of the infra team can easily pull the code base and get the latest state files. So basically, the state files are remote. And that is an overview of the infra repo. Okay, it seems the build is done now. So the build is done now. We can go over to artifact registry to confirm if there is a new update. So we'll come over to the artifact registry. Oh, perfect. We have a new update here. So it released a minute ago. So I want you to take note of the commit hash. You notice that the commit hash here is 236607. So if we come over to our cloud report, you notice that there's a release currently going on 236607. It's pulling directly from the artifact registry. But before it deploys to the Mahab test, I want to show you what is currently on the Mahab. If you look at what is currently on the Mahab test, okay, it seems it has deployed. So everything has been updated, software developer. You notice that everything is working perfectly well. So yes, so it has been updated. So it has been released into the testing part of the pipeline. So that's why it is showing software development. But here's the thing. It hasn't been released into the staging part of the pipeline or the production part of the pipeline. So I want to show you what we have currently in the staging part of the pipeline and the production part of the pipeline. So what we have currently in the staging part of the pipeline is showing you staging part of the pipeline. So what we have in the staging part of the pipeline is software engineer and software engineer. So what we have in the testing part of the pipeline is software developer. So here's the thing I want to show you, the beauty of the cloud. So the moment I click on promote, that means that I as a developer validated that everything is working perfectly well. We want to promote it to the staging part of the pipeline where the Q&A team can do their testing, the commercial team can do the testing. So the moment I click on promote, see the staging part, and here everything is stable. We promote. So review, okay. This is where they require approval through assets in the infra testing console. So require approval, needs approval. So then I approve that. So it is currently building. So the moment I refresh the staging part of the application, which is this, you notice that this will change to software developer, and at the same time, this will change to software developer. So you might be wondering, how is it deploying directly to cloud when immediately? So cloud deploy handles everything for us. So we basically have set the instructions in the application repo of what it should do. So it automatically handles everything. So it's still building. The minute it's done, we can show you where that goes. So the moment I refresh the staging part, you notice it changes to real local. Look at that, it works perfectly well. It has changed it. But when the Q&A team now does its own testing and we demo to maybe senior level officials and they're very okay with what we've done, we can then promote it to the production part, which is this. You can then choose to promote it to production. Well, if you also feel like, oh, this is not stable, or when you're in production, you feel like a release is not stable, you want to roll back release to like a previous Ash version, you can then say, okay, I want to roll out a release to probably the one that has the commit hash of 382 based on what is in. So that's basically an overview of how everything works. So moving on, we've gone over the application repo, we've gone over the infrastructure repo. So what are the challenges I faced? So I faced three major challenges basically. Initially, I had issue connecting the cloud view trigger to the GitHub application repo. So I had to get a personal access token from the application repo in the organization it is. Then I added it to the secret manager. Then based on that, I was able to create a connection using the cloud build v2 connection using that secret key personal access token. Then I was able to set up everything. Then I also faced issues when I was trying to set up the cloud view. Basically, it says the default service account will not able to perform the build. So I had to create my own service account, a user managed service account. And that basically handled the build failure and it was perfectly well. So I used this app builder say, let me show you in the code base. With that one handles everything that has to do with cloud build. That's and the service account for cloud build. I need to do the default. Then exactly. So I initially I wanted to define everything that had to do with instruction to set up each stage of the pipeline to cloud run. So I wanted to do the instruction set. Everything should be in the service the YAML file, but I couldn't get it to work. So that was why I had to use customize. So we separated everything. Customized based on whatever I set in the customize. So whatever I set here, so customization YAML file, and I created an overlay for each of them for production, for staging and test. So that was how I was able to do the separation of concern and get everything to work perfectly well. And what are the key takeaways? Whenever you're working with service account, I would suggest you do give it the least privilege as possible. So you shouldn't have a wide access to permissions. You give it the least privilege. So it means if something happens where you lose someone else gain access to your keys, they will have limited permissions. So they won't be able to access something else you gain additional from. So always give your service account limited permissions. And I use Terraform to handle my infrastructure setup. So in case any member of the team wants to check out what was done, or if I'm no longer in the organization, someone wants to see how the infrastructure was set up, Terraform offers a good way to set up your infrastructure that anybody can understand and then how it works. So I also use Google Cloud Deploy to handle the deployment of the multi-stage rollout and also logs, patience and logs. So whenever you're doing anything that has to do with infra setup or software development, logging and the logs you see are some of the best ways you can help you fix the issues you are facing. So the logs are basically your best friend, and logging is a journey. So thank you very much. I hope you all have a wonderful day. And if you need access to the slides, you can check it out there at the infrastructure repo. Thank you very much. Have a nice day, everyone.
Thank you very much. That was really good. It was good learning more about GCP as well, because I personally haven't really worked much on GCP, so that was nice to see. What do you think, Patrick?
GCP is awesome, very, very awesome. At least I got an opportunity to tinker with it a bit, but mostly I've done a lot of my work with AWS. But that was really, really nice to see that again the agnostic nature of the Terraform tool has been demonstrated to us. That was very, very nice. Thank you so much for that presentation. Yes.
Awesome. Thank you. So our next speaker is, before we move on to our next speaker, we have an announcement. Remember, we will be sharing all of these talks on YouTube in the coming weeks. So if you're just tuning in, you can catch up later as well. Also, join a HashiCorp user group chapter, and there are like 14 HashiCorp user groups in the continent of Africa. So located in Cameroon, Ghana, Kenya, Nigeria, South Africa, and Uganda. So we hope you will join one of those near you, or that you will start your own. So our next speaker is Kevin, and he leads the Meru HashiCorp user group in Kenya. Kevin is going to talk to us about DevOps learning on a budget, so lessons from Terraform challenges and game days in Africa.
Karibu sana, Kevin.
Happy to be here for my very first HashiTalks Africa. I believe this is going to be the first of many. And just to get right onto it. Okay, so just to confirm something. Okay, good, I'm good. Okay. So my topic for today is budget. Lessons that I've learned from running Terraform challenges and game days right here in Africa, in Nairobi, Kenya. Just before I go on, I'm a cloud and cybersecurity consultant. I also lead the HashiCorp user group Meru, which is one of the 14 HashiCorp user groups here in Africa. I'm also a leader for the AWS AIML user group Kenya, which is actually the very first and only specialized AIML user group right in the whole of Africa. And I'm going to tell you the reason why I'm also putting that out. Okay, so we start with a nice question to get us all. I know you've been all technical, but this kind of, think of it like a relaxation commercial break, because you're going to learn a lot of these We're not going to be that technical from what we've been getting so far. Ourselves is how can a community, a HashiCorp user group, impact the life of a techie or a wannabe techie? That was the question we had when we formed our HashiCorp user group, Meru. And as you already know, that the best landing point from all the HashiCorp products is Terraform, because it is the most widely used infrastructure as code tool and the easiest way to get acquainted into the HashiCorp ecosystem. So we said, okay, let us run a Terraform challenge. And if you look at the numbers, because the numbers never lie, there's a 30-day Terraform challenge. Within it, we also had 2 webinars within it. And we wrapped up the whole challenge with a physical event. And we had a challenge repo. And that repo, I actually was managing it solely. I was the only one actually dealing with the merging and the closing of the pull requests. And we had over 95 of them. I definitely had a team of HashiCorp user group volunteers. Our HAG had a good number of volunteers, and we also brought in volunteers from the AWS user group to help me in running this challenge. We also ran a game day, a Terraform game day. And this started out with a very simple conversation, just deciding to take action. I saw a LinkedIn post from Chris Williams saying, hey, if you are running a HAG and you'd like to run an AWS Terraform game day, please ping me. And that's exactly what I did. And a couple of conversations and email threads later and support from the amazing HashiCorp team, we had over 20 gamers. We also did one pre-event just to warm up the gamers before the game day itself. And then we did one physical event at the LX Kenya hub. And we had 5 winners at the end of it all. And from the 5 winners, we also got 3 of them getting the Terraform Associate certification. So numbers never lie. That was an impact in this case. So the question would be, how did we pull these off? Definitely, you also remember that you have to do it on a budget. And most communities don't get a splash of money and funding to do this. So we had a 0 budget. That means that you're not getting any like $1,000 here, or $500 there to run the challenge. That means that you also needed to make sure that you manage the expectations of all the stakeholders. But the beauty that we had is we had community collaboration. That means that we did not decide to do these alone. We brought in several communities together. For example, the AWS user group came together with the HashiCorp user group. We from the HashiCorp itself, and we also had the venue support from LX, which is an arm that is having this mission of building capacity of over 3 million Africans by 2030 in technology. So definitely we are also supporting their mission. And as you can see, this was the first post I made under our AWS user group. It was actually, I can remember it was almost like a Sunday of sorts, or a Saturday, our Terraform. And what should we expect? You're going to get some beginner-friendly learning resources. Registration fee, nothing, nada. And as much as you're saying classes, we are expecting that you're going to be having each and every day something new to do. And I was building on my experience in the group around Yaoundé, where AWS Terraform Challenge, 30-day challenge, and I learned a lot from that, and I brought it here. And yes, we had Patrick, our HashiCorp ambassador, come through for one session during the 30-day Terraform challenge on the intricacies of local and cloud state management in Terraform. And it was a blast. I remember it was just a simple message here and then. They told you, Patrick, as much as you're busy, you better come through for me. I've ever come through for you, you better come through for me. And it was such an awesome scenario. And we also had and a member spotlight. Nelson Ngumo was like our most transformed person through this challenge. He went on from just knowing a couple of things around Terraform to getting certified to even blowing our minds off in terms of how we could have worked through in terms of improving the repo and awesome. Yeah, and then we had our members of Spotlight well improved, and we were so amazed. And then it brought us to another question. How can we make learning fun? And to answer that question, we said, okay, let us do the game day and let us see what it happens. And at the end of it all, when I see these posts from Nora Sad, when she was talking about being a beginner, because if you look at that second paragraph, she says, the challenges weren't easy for a beginner like me. Tasks like setting up Terraform state with S3 and DynamoDB, writing modules, working through provider issues. But she learned so much just by showing up and doing her best. And funny thing, she finished second runners up, a case of zero to hero because of gamification. And just to put it into perspective, because we ran this on the 9th of May at the LX Nation Center Hub, thanks to their venue sponsorship and a lot of support from HashiCorp, is when we said that you're going to be doing it, we also wanted to ensure that people put points on the board. That means that we needed to do a pre-event. We expected that some people will come through and they don't have any idea about infrastructure as code and Terraform in this case. And we ran these, and we had an amazing person, a friend of mine from Solavis Tech, who came through and provided a session on introduction to infrastructure as code and Terraform. And because of fun, you have to be goofy. And there are so many things. We had over 30, but as I say, 20 gamers, but around over 30 participants along the way, volunteers who came through. And as you're going to see, this is when we are having fun at the end, but this was when people are so serious. And if you could see the screen out there, we had Geoffrey from AWS and Chris from HashiCorp and they were wondering. 20 minutes in, no one was putting any points on the board. You could even see Chris was like, what the hell? Who are these people? Why are they not putting points on the board? I could feel like I was literally looking at that corner of those people and wondering, what are you doing? But at the end of it all, we had points on the board. As you can see, we had over like 10 or 20 people, over 125,000 points. Jeffrey was happy. I was relieved. And we had over 5 winners on that game day. And as you can see, these are how Nora Sad is the lady on the far right. We had Dennis, we had Brian, and a couple of other winners, as you can see there. And one thing I came to realize is that we don't rise to the level of our goals. We can set so lofty goals when it comes to learning, but we'll always fall to the level of our systems. That means that we need to take advantage and be keen on the systems that we set. And that means we also needed to take a step back and look at the learning journey. And we brought someone, a non-techie in Patricia, and to take us through on learning how to learn. Because sometimes when you're learning on a budget, you have to look at how are you actually learning? How are you making the most of that? And she took us through these. And to know how to learn, we learned a couple of things. And that question is, what did we learn? And our first lesson is you need to take on the challenge. Do it scared. I never knew, because I was trying to look at whether we've ever done a physical Terraform game day in Kenya or in East Africa. None that I could look to. But I said, let's do it. In terms of East Africa, in terms of a 30-day Terraform challenge, none. But I took my learnings from what we did in West Africa and brought it back home in East Africa. The second lesson is make learning fun. Find ways of gamifying learning. We set up a leaderboard in the game day challenge. We did it as kind of through some actions, GitHub actions, and it was so awesome. And reward. We'll give out some swag. As a hug, there's usually swag and vouchers and everything. Reward effort so that people can even get more and even reward yourself. And the final lesson was you need to review your systems. Even in this case of our lessons from our learnings, we are optimizing that for our second phase. We learned that we cannot pull ourselves thin. You cannot run a 30-day Terraform challenge one after the other, one after the other. You need to take a pause. You need to take learnings from it and then iterate to be better. If you'd like to check the challenge repo, you can scan the QR code. The URL is also provided. That was the challenge repo that had over 95 pull requests. You can also follow HashiCorp user group Meru right on Meetup. We'd love more members. And also, if you would like to get an opportunity to speak to our members, feel free to reach out. And as that, you can also reach out to me on any of your socials on Prairie as Kevin Tui. Thank you so much once again on HashiTalks Africa.
Thank you, Kevin. That was really insightful, and I'm hoping we could do something similar here at HashiCorp User Group London. Patrick.
Yes, Kevin, thank you so much. That was really good. That was really good and really eye-opening. You have taught us that it is always important to continue learning and also to continue building. One thing I like about Kevin, because he's actually a friend here in Kenya and he mentioned me, so I have to pay it back, is that Kevin is always concerned about community. And he's doing a lot of good things for communities down here. And I'm looking forward even to further collaborations so that we can continue to popularize Terraform and HashiCorp tools down here. So thank you so much for that. Wale, are we ready for the next?
Yeah, we are. Funny enough, the next speaker is also our final speaker for today. And his name is Adefemi. And he's going to be talking to us about Terraform and Gen AI. How he created a weather chatbot AI agent. So.
Oh, sorry, Wale. Before Oh, sorry. Before that, I think Nelson will be coming after Adefemi. So Nelson will be our last speaker.
Awesome.
Awesome. Thank you.
Thank you.
Hi guys, can you guys hear me?
Yes, we can hear you. Just need you to share your screen.
Awesome. I believe I should be sharing my screen now. Is my screen being shared?
Yes, you're all set.
Oh, good. So yeah, thank you, Wally. Okay, and the other speaker, I can't remember your name now, sorry, for the quick introduction. So yeah, for today, I will be looking at this topic that involves Terraform and Gen AI. Basically just walking you through how I also use this to create like a weather chatbot agent. Yeah, so the name is Adefemi. Currently I work at Swisscom as a senior platform engineer. And also apart from that, I try as just possible to also have some hobbies aside from writing code and programming. So at the moment, I'm really involved in astronomy, and also like also playing games on my PS5 as well, which can be quite fun. Games like Ghost of Tsushima. Yeah, I think that's the only game I've been playing throughout this year. But yeah, that's it about me. And on Twitter, my username is DarinFagai. And yeah, I think on Twitter. So for today, like I mentioned, we'll be looking at Terraform and how we actually sync Terraform with Gen AI. I will try as much as possible not to spend too much time on explaining what Terraform is, because I think the initial speakers, they've done a really good job in actually explaining that. But I'll just touch some key points. And these are some of the subtopics we'll be looking at, right? So understanding how Terraform actually first meet with AWS, AWS Bedrock, which is the Gen AI tool I'll be speaking on in this case, but also understanding the behind the scene, how Terraform connects with Bedrock. But also I'll do a quick demo as well to create this Gen AI chatbot agent, and I will have interaction with it. And at the end of the day, I'll talk about outcomes and insights and like what the future looks like in the Gen AI world or in the AI world in itself. So first, let's speak on Terraform meeting with AWS. So with Gen AI, I think when I first heard about the whole AI thing, the first thing that came to my mind was this movie, this Will Smith movie, I, Robot. And I think most people also probably have the same thoughts initially that we would actually be at this spot right now, but unfortunately we are far from it. But anyway, Terraform in itself, I feel like in the past decade, I think it has been the most useful infrastructure as code tool ever that I've seen. Also, learning curve wise, I think it's quite easy to learn. A lot of users, like I said, have mentioned what Terraform is. So, as we all know, it's just an infrastructure as code tool that is developed by HashiCorp. And it is cloud agnostic, basically. So, which means we can use it for different cloud provider. As you saw earlier, someone was using it with GCP. And I think also someone shared how they use it with Azure as well. But I'll be talking on how I use it with AWS. The other point I also want to mention is AWS Bedrock. So this is like this is the Gen AI tool that AWS released, I think sometimes around early this year or last year. And the whole point was to actually improve agentic AI, right? Improve how you communicate, how you use AI. Basically, the concept was how you create generative AI applications and how you connect those applications with different data sources. So data sources like your API, API server, or even connect it with your knowledge base. And I'll speak on knowledge base as well. Knowledge base in itself, AWS Bedrock knowledge base, is just the behind the scene is an S3 bucket that actually stores information that will be used with your agentic AI, so with your Gen AI tool. In this case, I won't demo that because this app doesn't need any knowledge base in itself because we are just querying data that is coming from the internet. So we don't need any knowledge base in this case. And the interesting thing about AWS Bedrock agent as well is that behind the scenes it uses Lambda. So if you are familiar with how Lambda works, definitely using AWS Bedrock agents will also be easier for you because you just have to code your idea and you have to make sure the output is structured in a specific format. No. So I said behind the scene quite a lot in the last slide, but this is the actual behind the scene. How does Bedrock actually connect with Terraform, or how does Terraform link up with Bedrock? The whole point is, like I said, Terraform does the infrastructure as code path. Bedrock is the resources we want to deploy. And I also mentioned earlier, like Terraform is one of the best infrastructure as code out there. So the rate at which they also create providers or they create resources for some of the cloud provider resources is also quite fast. I think immediately when these cloud provider are releasing new resource, the Terraform community is already thinking of how they can actually create like a provider for this, sorry, I said a provider, a resource for the cloud provider resource, which is quite interesting. So the whole point of how this bridge link up is that Terraform will be the infrastructure as code tool. AWS Bedrock is where we actually want to deploy this infrastructure as code and also deploy our logic as well. And like I mentioned, behind the scene, AWS Bedrock is a Lambda function. So we will need the Lambda function, but also we will need the Bedrock, AWS Bedrock resource. And this is how Terraform actually links up with AWS Bedrock. And also, Terraform is a tool that is like when you deploy the changes, you can actually enable like automated deployment of those changes, just like it was shown to us earlier. Also, you can manage versioning of those changes as well, which is quite nice in this regard. So yeah, talked a lot on Terraform, talked a lot on Gen AI, but let's see this in action. Actually, let's see how all this connects. So I hope my screen is a bit bigger. So I'll try as much as possible to zoom in, so this can be clear. So what I've done is I also try as much as possible to use best practices of creating Terraform, which is with the use of modules. So I mentioned earlier that behind the scene, what Terraform Bedrock agent does is just use Lambda function, but also have some attachment that is added to it. So I've created my Lambda function. I've zipped the Lambda function as well. And what the Lambda function just does is to use this geocoding API URL and also this weather API URL to get like current weather, but also to get location. And then there are like quite some functions as well that are included in there that converts the location to a specific longitude and latitude. And then it returns the latitude and longitude and also the name of that location, and then the country of that location and where the person is. And at the end of the day, we also use this longitude and latitude to fetch the weather data for that specific location. So what we're looking for is temperature, relativity, humidity, just to understand like what is the weather condition like in that specific location. And also we are also looking at like just 1 day forecast. Like I said, this is just a test. And at the end of everything, we are converting the return we are getting from this guy. We are converting it into something that is understandable to you, man. Because if you open your weather app, you are not seeing longitude or latitude, right? You are seeing numbers that can easily be understandable. You are seeing letters like, oh, it's going to rain at so place today and stuff like that. Not 2000 and something, and then seeing longitude and latitude numbers that you barely don't understand. So we send this code, which shows like the weather condition, but also if the weather condition is unknown, I also send a string that says unknown conditions. And at the end of the day, based on those conditions, actually this was manually typed. So based on all those conditions, this then suggests you the sort of clothing you should wear. So if the temperature is greater than 30, 25 and stuff like that, it gives you all the kind of clothing you should wear. Also, this was like randomly generated, so it might be wrong. But also another thing that I included into this is the wind speed as well, and also the humidity. So it tells you, yes, it is quite humid. So wear something that is really nice, wear something you can feel comfortable in, and all those kind of stuff. And at the end, it just shows you the temperature difference. And so we send some of the response that we send with this suggest clothing is the weather specific, the wind advice, the humidity advice, just like I've showed above, and also the field advice. And at the end, I mentioned the fact that Bedrock agent uses Lambda, but the response is quite different from normal Lambda response. So with normal Lambda response, you can just do return, and then you pass in whatever you want to return. Or a good example is actually what I defined up here. So you can just do this, you can pass in something like this, and then you return a specific value. But this is not how the Lambda function that is being used by AWS Bedrock agent works. For that, it's quite different. So of course, I set in all my required values, but also call the geocode location package. And this is how the response will look like, especially for agents, for the AWS Bedrock agents. So it is expecting an action group. It is expecting the API path, also the HTTP method, the status code, and then the response body needs to be formatted in such a way. So it expects the response message and also the location, which is what we want to make this weather agent do. So basically suggest us, give us a message based on the weather condition, and also tell us where the location is. And if this is not found, it also gives like an next statement to say the location that you've passed in does not exist or something like that. So I can get those information. And at the end of the day, I also log in on exceptions on my Lambda log using CloudWatch log. If the response failed, so if something went wrong while suggesting the sort of clothes you should put on, the response state goes into failure. Also, we pass in the session attribute and also the POM session attribute. Now, why we are passing this is so if you want to keep your session, for most people that if you use ChatGPT or any Gen AI tool, if you are actually chatting with those sort of agents, you are creating a session while you're chatting. So basically, if you open a new ChatGPT chat, in this case, what happens is you also create a new session. And if you try to ask ChatGPT about the other session that you initially had, most of the time it won't understand it or it won't recognize what that session is doing because it doesn't have the session ID or the session attribute of the previous one. So basically, if you have two different ChatGPT tabs open and you are trying to get information across those two, there's a high chance it doesn't recognize it, especially if you don't create an account if you're using the free version. And then at the end, if we get an error or something, we return the error response, right? On the Terraform part of things, of course, I created my Lambda layer version because I'm using something called Power Tools. So basically, the reason I'm using Power Tools is because I want to see like X-ray, check like the tracing of my Lambda function. But this is not required. This is just an overkill. And then at the end, I'm also creating a rule that will be attached to the Lambda function, of course, attaching some policy to the rule. Some policies are really, really required because you want to create a log group, right? You want to create log stream events. And also, like I said, I'm doing some telemetry collection. So I'm also passing this condition as well. And at the end, I'm creating a resource for my Lambda function. Yeah, just giving it the basic information that is being required by AWS Lambda function resource. And of course, because I'm using Power Tools, I need like to create like the namespace and also the service name, also not required in this case. And also creating the permission for my Lambda function. Now the next thing is actually to create my Bedrock agent, right? So in this case, I'm creating an IAM rule that will be attached to my agents, attaching a policy to that IAM rule. Of course, depending on the model we are using. So the agent in itself, like I said, we've coded the agent, but the agent needs some way for you to interact, for you to get the information from the web. And in this case, what it needs is the LLM. So something like Cloud, GPT, and so on. And also, I want to get my knowledge base. Like I said, in this case, I'm not using knowledge base, but the code is just there to extend the code. And I'll speak on knowledge base just a little bit as well, because I think it's also quite something interesting. So like I said, knowledge base is more or less like the information that will be fed to your agent for your agent to recognize what it needs to do or what more it can do based on those information. So a good example is, let's say, for example, I have a list of websites where I get my clothes from, and I want to make sure when my agent is actually, when I'm chatting with my agent to give me this sort of clothes I can wear for a specific weather, and I want to also let my agent tell me where I can buy those kind of clothes from. So this is a good example of where you can use knowledge base. So you can easily either point your agent to the knowledge base ID, and in the knowledge base ID add the website of where you buy your clothes, or you can also create an S3 bucket, connect it to your knowledge base, index that S3 bucket using tools like OpenSearch, or I think they have S3 vector now, which also help with that. So you can vectorize a database, and then you can connect your agent to this knowledge base and use it in your agent. But in this case, we don't need that. And the last bit is to create the Bedrock agent resource. Also, passing a description. I think the most important thing in this case that, okay, not really important, that I also want to mention is that this Lambda has a timeout, right? Based on the amount of time to leave you set. I think by default it's 15 minutes, but I think they've changed it now. Like you see, I set mine to 60 seconds. Also, knowledge AWS Bedrock agent also has a limit. So it has something it called the context kilobyte, I think, and it's 25 kilobytes. So if your response that you're getting from your agent is more than 25 kilobytes, your agent will fail. That is how AWS have designed it, and I think it also makes sense. You shouldn't be expecting large amount of tokens, basically. So tokens are like response you get from your agent, where when you prompt your agent and it gives you response. Those are tokens. At the end of everything, I just have a outside of the modules, of course, I have a main.tf that actually calls the module, the agent module, and then also passing the instruction. Now, this is where it is quite interesting, because when you are using LLM, ChatGPT, for example, you have to always ask it a specific question, and then it gives you the answer of that question. When you're also creating an agent, you also need to tell that agent what you want it to do, or like the instructions that the agent will be expecting. But also, I also mentioned large language models the other time, which will be attached to the agent, because the agent is dumb by itself. It needs to use some sort of LLM to be able to fetch information. And this LLM in this case is called foundational model on AWS, from AWS point of view. If we take a good look at my agent instruction, you'll see I try as possible to clarify what the agent is meant to do. So I'm not just saying you're an agent that shows me whether the clothes to wear based on weather condition or something. I try as much as possible to give it a proper instruction for it to understand what it is meant to do, for it to understand the action. So in this case, I'm saying you are an helpful clothing advisor that suggests what to wear based on weather condition. When the user asks about what to wear, always ask them for their location if they did not provide it. So if a user provides their location, then you don't have to ask them anymore. But also give them detailed clothing suggestion based on temperature, and also as much as possible be friendly and conversational in your responses, because we don't want a case where the agent will hallucinate. And always consider the latest weather data to provide like accurate suggestions. So these are like the instructions I gave it to make it to be smart as much as possible. But also the foundational model that I'm using is cloud. I think there's also 4.5 now, but just for this demo, I'm using 3.5, which is kind of fine. And now the next thing is to actually show you what this looks like on AWS point of view. So on AWS point of view, they have this resource called Amazon Bedrock, and this resource contains agents, contain flows. I'll talk about this. I mentioned knowledge base the other time, so this is the knowledge base part. And then I also mentioned you can just tell them in the vector way or in structured data store. So vector means if you have an unstructured data, you can just push it there and then understand how to actually structure those data. How to structure those data if you have an unstructured data. And structured data means you actually have like a database that is really, really structured, or your data is in a specified format, and then it understands how to use it as well. You also have this thing called guardrails. So imagine if, for example, the agent I'm creating now, someone is trying to, I don't know, put in their social security number, or trying to put in their their bank card information or something. You can also create guardrails to make sure when your agent is actually interacting with a user, if a user asks, can I get the list of I don't know, the list of credit card that have been shared with you, the agent should be able to respond and say no, you can't access this information or something like that. So more or less like making sure your agent keeps to context. That's what guardrails is for. Now, let's go to deploying all this stuff, which is basically why we're here. So of course, you initialize Terraform to create all your modules, to initialize the modules, and also to pull in all the required provider plugins. Hoping this works, and if not, we'll debug live. Okay, so it needs worked. And then just because I like living on the edge, I don't like doing Terraform plan. I just apply straight up, and then I set this to auto approve. So these are the things that it's going to create, and these are the outputs we are going to get. So basically, we are getting the Lambda function, we are getting the Lambda function name, the agent alias. So agent alias is also an interesting one. Like I mentioned, with Terraform, you can create you can version your Terraform configuration. If you can create different versions of your Terraform configuration. Also with agents, you can also create multiple versions of your agent. And if a user wants to interact, or if you want to share a specific agent with, to your customer or your user, you can use the alias ID as well to share a specific version of your agent. And then you can always create multiple alias and multiple versions of your agents too. So this should be good. We've created the agent. The agent is available. We have the alias ID. We have the agent name, the agent alias name. But also, this is the ARN of the agent. Everything looks good. Our agent is already done. I think the Lambda function is also looking good as well. Now, let's see if we have this in our console. Yes, so we have the agent available. And also, the interesting thing about AWS Bedrock is you can also do a live test right here in your console. Another option is to use Streamlit. I actually wanted to demo that, but it's going to take quite a lot of time to set that up. So let's say, let's ask a weird question that is not in the context of what we've created. So where are you currently located? So I mentioned at that time, you need to actually tell the agent where you are. This is a condition that was passed in my instruction, right? So as you can see, the agent is saying, yeah, I don't understand what you mean. You need to actually provide me a location so I can give you accurate clothing suggestion. So let's say I'm in Lagos, for example. I am currently in Lagos, Nigeria. The reason I'm putting Lagos, Nigeria is because there's also another Lagos in Portugal. So it might be dumb to think of the one in Portugal. So I'm currently in Lagos, Nigeria, and what does the weather look like? Then what it does is it picks the location, just like what we've mentioned, and then it tells you based on the current weather, the temperature is this. And also we can also check Lagos, Nigeria weather. I mean, close to correct, 30 degrees, but it's saying it is 28 degrees, so not far-fetched. Anyway, and then it tells you that the weather is partly cloudy with a humidity level of 79%, gentle breeze, blah, blah, blah. Overall, it's telling you it is warm and slightly humid. And then it's asking, would you like me to suggest some clothing, some clothing, would you like me to give you some clothing suggestions? So I can say yes. I mentioned the session ID the other time, right? This is because I'm still in the same session. That's why I can just type yes, and then it understand I'm saying yes to this question it has asked. Just so it gives us like what to wear. So based on the current weather, you can wear these. You can wear a top, short sleeve t-shirt, bottom, blah, 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 the kind of footwear, the kind of accessories. If you need an extra layer, also it tells you you should use sunscreen. Now, another thing we can also ask it is, I'm going hiking in Austria. What do I need to bring along? So what this also does is it looks like, oh, Austria, and now it asks for a specific city. Let's say Vienna. And now it's also asking me when I'm planning for this trip, which I didn't see. Hopefully it gives us a good information, regardless of when I'm planning for the trip. Yeah, good. So it's saying, yeah, currently the weather in Vienna is 18 degrees, which is probably quite a bit cold. And then also telling me about the wind speed. And for hiking in Vienna, it's telling me the kind of clothes to pack along. As you can see, it's also suggesting what you can need when you're actually going to hike. Also suggesting food, also suggesting camera if you want to take like pictures and all those kind of stuff. And in reality, if you remember, I didn't pass all this into the agent. So now this is the LLM doing all this job. The agent is giving us what to wear and the kind of clothes, but the LLM itself, which is attached to the agent in this case, which is cloud, is the one going as far as possible to say, bring a camera, bring sunglasses, use your sunscreen, and all those kind of stuff. I didn't pass that to the agent. And also still telling us charge your mobile phone and all those kind of stuff. So this is like how the LLM extend what you've developed with your agents. So yeah, that's the demo. And the next thing is the outcome and insight. So we can see it is quite easy to build all this stuff. Now they've given you, AWS has given you the power to actually build your own chat GPT in this case, or build your own tool or whatever, and then use that tool in any way you want to use it. But also I think the interesting part about all this is that they've also giving you a way to Terraform has also been nice in that sense, whereby you can easily create all these resources using infrastructure as code, and also deploy faster, and also keep your state of deployment, and also share those deployments as well across board. I think the next thing, or what the future looks like for AI is that now you can see I'm creating different. I'm having a Lambda function that is connected to my agent. If I want to do something else, say for example, I want to ask the agent, should I go with my car or should I go with a bicycle or something? I might need to also create another Lambda function and attach it to the agent. If I also want to do something else, I'll need to create a Lambda function. So this means for me to have a good process of my agent to be able to have this full full power to do whatever it is I want to do, I need to create multiple lambdas. But things have shifted, I think, for the past 8 months or 9 months or thereabouts into MCPs. I won't talk much about it because this is not what this stuff is focused on. But things have shifted into the MCP world, whereby you don't actually need to be creating all this lambda. You just need to be consuming what someone else has created and then use it, and you don't have to go crazy about it. And AWS also have that as well. And I think also there's a Terraform resource for that. But that's how the future looks like. The future is that you won't be creating multiple lambdas anymore. And even if you need multiple lambdas, it will just be based on a specific need. Yeah, that's everything from my end. Also, if you want to follow me on Twitter, it's the InfoGuy. The repository is currently available on GitHub, so you can pull it and also test it out on your local environment. And also maybe make some merge requests if you see something interesting you want to do. Thank you.
Thank you, Adefemi. That was very insightful as well. Yeah, Patrick, what do you think?
It's awesome actually to see how one can combine Terraform with AI, Gen AI, to do amazing stuff. And
Yes.
I've actually enjoyed that demo. It shows you the thing that you've built in real time. One of our speakers had mentioned something that may the demo gods be with be with him. So
Yes.
sometimes you come to present and then you run into issues. But I'm really happy that this one has gone softly. And thank you so much for that presentation. It was really a good learning experience. Yes,
Yeah.
Wally.
Yes, and I will just to add to that as well. I haven't personally used Bedrock before, so it was good to see that live in action. So that was good. Right, before we move on to the next speaker, we have an announcement to make in regards to HashiTalks 2026. Sorry, just bear with me. All right, so yeah, sorry. Mark your calendars for the HashiTalks 2026, the 8th annual 24-hour virtual event for HashiCorp users that follows the sun will take place February 19th to 20th. And visit hashicorp.co/HashiTalks 2026 to register. You can see the link down below. So yeah. Now let's introduce our final speaker this time. And our final speaker is Nelson. Nelson is going to talk to us about going from monoliths to GitOps. So automating financial systems with HashiCorp and Kubernetes.
Hello everyone. I hope Patrick, I'm well audible. Please confirm.
Yes, we can hear you. We just need you to share your screen.
All right. Sorry about that. Please confirm you can be able to see my screen.
Yep, you are all set.
All right. Thank you so much. My name is Nelson Umo. I'm a DevOps and a cloud engineer. And I'm so happy to be here at HashiTalks Africa 2025. And I want to maybe first talk about myself and what I do. I'm in banking and financing, where I'm a head of IT. And basically, as my past speakers talked, Kevin Toure, he has been my mentor. Actually, we were together in the 30 Days Terraform Challenge, and Kevin should be one of the personnel who were able to get certified on the Terraform certification.
Hey, Nelson,
yes.
would you just at the top where it says from current slide, would you click on that button so that we can expand your presentation?
Yeah, thank you. Awesome.
Perfect.
All right. So my topic is about from monoliths to GitOps, how you can automate financial systems with HashiCorp and Kubernetes. Basically, before diving maybe to the organization story, it is important to understand that African financial institutions operate maybe most of the financial institution organization rely on legacy system and manual processes. including on-prem database and minimal automation. Then that the challenges, infrastructure challenges like unreliable connectivity and power outages impact service delivery and continuity. And then we have there's a human factor. We have limited to DevOps skills, and then change to resistance and also tight budget. So we look at the landscape. So we imagine a financial institution trying to process thousands of loans application only to have the system crash because it's running on a monolith system. So monolith system, maybe I can explain, it's a system where all services depend on one source of code, but in microservices, each service is dependent on itself. Maybe, for example, you have a system where you have a website where you have add to cart button, you have the login button, you have the payment button. Each process is dependent on itself. So if a customer has already logged in and the login module has an issue, it doesn't affect the customers who are already logged into the system. So another thing is that's hypothetical, and that's the daily reality of many African institutions. Probably my proof of concept is over 25,000 circles in African continent is they lack ambition, and that's many are still tied to outdated infrastructure. Then the modernization done. We are moving from on-prem monolith system that are siloed and hard to scale to hybrid that are cloud-native architectures built for agility and security and automation. So the goal is to empower institutions to compete with fintech players and also meet client expectation and also maintain the compliance without sacrificing uptime and control. So basically, Terraform empowers the organization to deploy infrastructure on a different cloud solution, maybe Azure, AWS, simultaneously, and also maintaining consistency while leveraging on each platform. So for instance, Azure can host core financial system like core banking system, while AWS handles scalable workloads such as mobile APIs, reporting engine, and analytics. So we also have GitOps. So GitOps with Argo CD bring the same rigor we apply to code to our infrastructure and deployment. Each challenge is tracked, reviewed, and versioned in Git, meaning that we always know what's running in production and who changed it. So Argo CD continually syncs this state to Kubernetes clusters, automatically rolling out updates and reverting to a stable state if something breaks. This builds confidence and compliance, what we need for fintech systems as well. So in financial environment, sovereignty of uptime and uptime are non-negotiable, and that's why we design or use hybrid approach. So some workloads such as databases remain on-prem for data protection and management because most of the countries don't allow data to reside outside the territories of the countries. So we use API management and logic app to connect core banking system, mobile apps, and backends. Then for high availability and to reside data on-prem, we use Proxmox virtualization and QNAP storage to deliver redundancy locally, while Azure suits recovery as well. So basically, I'll move to get hand-on a bit. So this, I have a presentation here. It's what I can call it is how financial services application goes from a developer to serving customers in the cloud. I have set up different modules. So here we have Terraform. Terraform is able to be able to help us manage our infrastructure. So from here we have the main.tf, where I've been able to set up the remote backend. So I'm using Terraform Cloud. Probably I can be able to showcase that. From here, I have created a workspace. So this is a workspace that I've been able to create. So this workspace is integrated with my GitHub. So I've been able to link my GitHub account with this. So you can also be able to do that. And then you do a version control trigger. And then from here, I've been able to set up variables that I need to manage within my environment. That is the database name, the database password, the user. And then I also have the AWS access key and the access ID for communicating with my AWS account. So basically what is happening, unfortunately I have an error here, but I hope to correct that. But I hope you'll just understand what's really happening. If I can present my code here, and what we are doing is customer want to check account balances. So I've been able to create microservices from here. I've been able to create a microservices for account. Basically, it is in the banking and circle industry where you maybe want to get a loan, you want to confirm your balances. So here we have an account, and then they have a service here. This service account is linked to this code that is running here. That is checks that the service is making sure that the service is running. It connects the database from here, and you can be able to see that I'm not being able to encode my credentials. I'm fetching my credentials from AWS Vault. I'll be able to showcase that. Then it is able to select the balance, and then to give you the callback or gives you the results. So I've linked that with a Docker file here. So this is one microservice. Then we have this another microservice here. This is a loan service. So the loan service, to make sure that the loan service is running, and then to give you the number of disbursed loan, can be able to disburse a loan for you. So the same thing is happening here. This is a deployment now for the loan deployment. Then now we have the API. The API now is able now to communicate with the database. So from here, we have this API here. So this is an API gateway. It links, it fetches the details from the database, and also using, it's able to fetch the summary details from the database of the account URL and also the loan URL. So it's able to give you the callback. Then from here now, something else is, I have a secret source. So this is where I'm doing my AWS secret management. So I'm using AWS secret management to manage my secret. And then from here now is the Vault secret management. This is an external secret. It restores the key for Postgres database, the user, and also the DB password. So this one, it's able to fetch from this secret.tf. So what is happening is I am able to deploy a secret manager using Terraform. So I'm managing my infrastructure in that way. And then I fetch the database credentials. Then I tell this service to only go and read the database credentials only, not to do anything else. Then after reading those database credentials, to input them into the Kubernetes secret manager from here. Then after there, we have the secret operator. which reads from the service account. From here now, we have another automation that I've been able to do. When I do, probably I do Terraform. I do Git. If I do Git push, I'm able to push my code, and resources are being able to get deployed from this workspace here. You can be able to see that I'm pushing my code from GitHub. So every time that I push my code GitHub, the Terraform checks if there are any updates, if I've made any changes to my infrastructure, and it does the update. So I'll take you through what each and every file here is doing. So this is an Agol TF. Agol TF is it's a GitHub operation that manages Kubernetes. So it installs Argo CD via Helm. So this is just an installation of Argo CD. Then Argo CD depends on EKS cluster. So it will do the deployment through the EKS. So it must wait for EKS to be ready. Of course, Argo CD cannot proceed with the installation if the EKS cluster has not been ready for communication with the Argo CD. Then here we have the Argo CD definition with the region and the metadata, that is the namespace, and also creating the name. And then now it depends here. It depends on the helm.release. So it depends on every release that it does. Then here we have the EKS. This is our cluster. We are creating our cluster from here. So we have the VPC modules. So we are creating private subnets and also public subnets. I believe private subnets will be used to communicate with the Postgres database, because our database has to be in private subnet. So, and also now we have the public subnets. Then we have the NAT gateway for private subnets. And then now we have the this is a VPC that we have. I'll be able to show you how these resources have been created. Then now we have the cluster module from here. We've been able to create the module AKS, then create the cluster name, and then give it the permissions, and then even the instance type. Then we have the how many node should always be running in that regional zone. The desired is 2. The minimum size is 3, and the maximum should be 3. Then the environment is the demo, and the project you're calling it a kit. So this Kubernetes.tf, it is just when you do Terraform apply, it synchronizes with Argo CD to apply your auto applies your manifest from here. So it deploys your resources to Kubernetes. So this is an automation we've been able to do here. Just it's able to check from this folder and apply the resources. Then we have output. Output now is what we are going to get the output as after the resources has been deployed. So we have the module, we'll get the cluster name. Then we'll have the database instance endpoint, that is the API endpoint, we'll get it from there. We'll get the VPC ID, and also we'll get the EKS console, that is from here. Then we have the RDS, we are deploying a Postgres database, just a small database. Remember, we had deployed some subnets. So this is where now the subnet will come to place. We'll be using the private subnets. Then identifies Phenops Postgres. The engine is Postgres, just a small database. Then it fetches the details from there. You can see fetches from the variable. We've not got any variables from here. Then we have the subnet group name, and then the snapshots. Of course, this is a very important place because we need to do the backups of the database. Then now we have the secret. So I've had explained this one. I think I had explained this one. This is managing the secret. Now we have the variables here. The variable basically it's a description of the resources that we are creating. We are creating an AWS resource in US East 1. Then we have a variable for database. Then we have variable for DB name and financial the DB user. Of course, these ones should not be hard-coded like this, but in production, you should call a variable to be able to define the secret. So basically, maybe from the infrastructure that I've been able to deploy, can be able to showcase from here. Perfect. So these are the resources that I was able to create. And then basically I have an issue with creating the AWS DB instance. That's why you are getting an error. I think it's something that I'll look to it. Then we have created a security group. Then we have the Helm release for the Argo CD. Then we have module for the CloudWatch, and all these other resources. We've been able to manage them through Terraform and Terraform Cloud, through Terraform and Terraform Cloud. Then basically now you don't need to manage your backend storage, because Terraform Cloud Platform already manages the remote backend storage for you. And then these are also a good some good style of doing infrastructure management, because if you're working as a team, you'll have consistency of the infrastructure and you'll not be able to break your infrastructure as well. If we go to AWS, I can be able to maybe showcase you the resources, how they've been created. Can check if the cluster has been created as well. From here, we can be able to see that the cluster has been created, and then the cluster is up and running. We have the resources from here. Then if I go back here, I can be able to go here to the EC2 instance and check the nodes. From here, you can be able to see the nodes has been created as well. And then from this other point, you can be able to see our VPC as well. So from here, yes, so we have this VPC. From this VPC, you can see the route table or the resource map. So it has route table and as well as network connector. So this API is able to use a load balancer to be able to always have a high availability and communicate with the database, as well as the loan deployment module, as well as the account management as well. Something else maybe we can check is security groups. From here we have the security groups as well. we can be able to see that we have the FinOps EKS cluster, and then we have the FinOps VPC as well. And then we have the NAT gateway as well for managing our private IP as well. Basically, that's it. Because of purpose of time, still debugging some errors here and there, and probably I can show you from here what could have really happened. So basically, if this node was able to get deployed, of course, I have this error here. After this node is deployed, we'll be able to deploy our K8, and then we'll be able to get our FinOps resources as well. So basically, that's it from me. We can catch up on LinkedIn. My name is Nelson Momo. I'm available to collaborate. Thank you so much for your time. Thank you.
Thank you, Nelson. Thank you. That was also very, very good. Yeah, Patrick, I'm guessing you know Nelson as well then?
Yes, I do know Nelson. Nelson is also from my country. He's a wonderful engineer. He's a wonderful engineer, and he has also shown a lot of initiative in terms of upskilling. You heard Kevin mention him as one of those people who actually went on ahead, finished the 30-day challenge, and even certified. So that is awesome. That is awesome. Congratulations, Nelson, on your achievements, and that was a presentation well delivered. Thank you.
Yeah, well, I have to second that actually as well. That was a nice presentation. Thanks, Nelson. So this wraps up the entire event. Before we go, just quick reminder that remember, we will be sharing all of these talks on YouTube in the coming weeks. So if you're just tuning in, you can still catch up later. Also, mark your calendars for HashiTalks 2026, the 8th annual 24-hour virtual event for HashiCorp users that follows the sun will take place February 19th to 20th. Visit hashi.co/HashiTalks 2026 to register. And the call for proposals is now open as well in case you're interested in delivering a talk. Also, finally, join a HashiCorp user group. The HUG program spans the world in 65 countries with over 59,000 HashiCorp users across 190 chapters. There are 14 HUG chapters in Africa, and we want you to join. So visit hashicorp.co/hugs to find chapter near you or learn how to start your own. Thank you very much.
Thank you, everybody. See you in the next.